Good evening, everybody. Monday, the 28th of August, 2017, Sun and Moon back today with, or I should say, watching, and hello to everybody in the chat room. On the panel so far this evening, we have Patricia from the UK series from Holland, and we have Paula from America. Oh, bad Christian. She has joined us. It's very encouraging that this time it's a lady explaining it, but she's found all sorts of anomalies and checking and researching, and it's just really great. And so what she's going to do is she's going to talk about the things that she's found, and they match Chris's work. So over to you, Bad Christian.
Okay, thank you for that very nice intro. And what I think I'd like to do, as I mentioned to the panel beforehand, was that I have more introductory material for what I think Chris is going to present later, which is a little more involved. And a lot of the stuff, if anybody has seen my videos, is already on there, but I wanted to recap it for everybody that isn't familiar with it. And okay, there we are, we're presenting. So what I got here, just to get right into it, is trying to illustrate the issue with sun paths and how that is important in any Earth model. I don't care which one, a ball Earth, heliogeocentric, flat and round, flat and square, doesn't matter. They all have the same problem with how the sun moves over the sky. And these were images I found online that try to illustrate how that works in different, from Earth's perspective. Usually you see something like the bottom picture where we see from out in space somewhere looking at the sun and how the Earth goes around it. But when you're standing on the Earth and you watch the sun go over, you notice some things. And this is something I observed I started really watching the sun at the solstice. And I noticed that it rose north of east, set north of west, but when it was at its highest zenith, its solar noon, it was not 90 degrees overhead. It was tilted toward the south by 20 degrees. And this matched timeanddate.com. And the same thing is true in the south, where the equivalent latitude in the southern hemisphere would have their zenith pointing toward the north. So both hemispheres, just to use that term because we all know what it means, not necessarily that it's the right model, but both hemispheres, north and south of the equator, their sun path arcs toward the equator. And it does this every day at every time zone. As the sun moves along, it has to keep making this kind of east to west movement, and it's tilt toward the equator. And that's what these little drawings are illustrating. I replaced the one in the middle just because it had some angles marked on it that the others don't. That's where we get our 23.5 to the tropics. And by the way, tropic is from the Greek tropos, meaning to turn. So it's the turning point of the sun. And all it means is not the farthest the sun goes straight across, but the farthest, it kind of does, but it's more accurate to say that it's the farthest north or south of the equator you can go and still see the sun 90 degrees overhead. Every place else is going to be some lesser angle than 90. And we can see here's the Tropic of Cancer on the second row on the left. It never goes 90 degrees. Its angle just changes a little through the seasons. And the mirror image is true in the Tropic of Capricorn. And supposedly this picture on the bottom explains that, but it really doesn't. And the fact is that these people get confused because these lines, if you were to put, they have the sun in the middle just to show that, the summer and winter solstices. But if you were to put like these arrows as lines that are like a pencil point and you spin the ball at that angle, you will get these lines. So these make sense, but the problem is they don't account for the sun movement. You would think by looking at this that it's, as it spins in the ball model, that the sun is going to do exactly what we see, something like that, one of these tilts. But this is the east-west line. That's not the north-south line. The north-south line is from the true north, which our pole of axis, and by the way, the sun's pole of axis roughly point to the same thing, which is Polaris, and that's where we get true north as opposed to magnetic north. But the point being, this is a standard model, and it puzzled me that this sun movement did not match that, and it doesn't match any other model, because how do you account for the sun's arc toward the equator as it goes along the sky on any given day? Not even considering seasons, just on a given day, one rotation of something where the sun passes over, that non-straight up and down path except at the equator doesn't make any sense. So what I did was I also, oops, sorry, I didn't mean to change that picture. Sorry about that. I've got a bunch of them here to show, but that's just briefly to explain what the issue is with how the sun moves and why we need help with our models. And what I have here is, I think, I wish it would stop doing that. I keep scrolling when I want to just zoom in and use the scroll bar.
You're okay.
Okay. At the top here, we have what most people would consider the standard dome model, where it's kind of on its side, where we're on the Earth here at this center point, and this is or at the bottom of here, sorry, and this is our firmament. But it doesn't work with those angles I talked about, because they're arcing the wrong way. They're not going toward the equator, they're going away from it. And so this shape doesn't work for me optically. And these are actual pictures of actual light beams going through a real lens. So they're not reconstructions or calculations. And so I thought, well, what shape does work? This is a converging lens, because the lines converge after they go through this lens. And by the way, if anybody doesn't know, you can't bend light unless you have a change of density. It has to change. So we need those two factors, the shape of the lens and the fact that there is a lens, so that the light has to pass through something different in order to make it bend. Well, this is bending the wrong way. So we need a diverging lens, which is the second one here, the double concave lens. And it's, as you can see, it's caving in on both sides. That's what concave is, how you remember it. But the light beams come out, and then they splay out like this. So if we're Earth on this side, that's the path of the sun, basically. It's bending in toward the middle. The middle is straight, and the light is bending in toward the middle. Why it does it is because light bends toward the thickest part of the lens. And that's just, what shape you would want. You want the thickness on the outer edges, so it will try to go there. And that's why that angle works for me. So if this is Earth and this is sun, where the light's coming from, we need between the two a double concave lens. So what I propose, first of all, did it again. Let me pull that back up. We have the ball model, okay? Whether it's helio or geocentric, doesn't matter. We have the Earth on the left, the blue, and then we have the sun on the right, the yellow. And each of them is surrounded by a bubble or donut or whatever you want to think of it as, with lensing properties, which is to say that it is some either magnetic or optical, doesn't matter. All of those can bend the light. But look between them. We have a change of density, and it's in the shape of a double concave lens. So the light comes straight through the lens, it bends out, and we have our angles that match observations of sun movement across the sky. And it doesn't matter how these things spin or which one spins, or if they spin, the sun has to move somehow over the Earth, but the angles are right. So how many times? It's just, I don't know. Someday I'll learn. So we go down to these two models, possible flat Earth models. On the left, we have the disk inside of a toroid or a donut. And we have the sun inside of a toroid or donut. And this is, as the sun moves around the disk, it's going around this other one. And between the two of them, we still have this double concave shape. So it'll work no matter what point you are on the disk and where the sun is. And you can see this kind of straight on in the square or rectangle Earth map. Think of this as like a cutaway of the other. It works the same way. We have the sun in some kind of magnetic or optical bubble. We have some kind of, even that top lens that I showed earlier. Let me go back there for a second and do it the right way. That hemispherical lens. And between the two of them, we have the double concave shape. And that would account for as the sun moves across, it goes straight up and down 90 degrees at the equator. Say that it's from the east coming west. And we have this angle at both of the extremities on the other side. So it works in every model you can think of, as long as you have a double concave lens between them. So that's the quick crash course on what I've been thinking about sun movement. So maybe I should stop and see if there's any questions.
You're not going to show the other pictures then? You're going to do that a little bit later on then?
Well, I can go on. I just thought I should stop there and, because, okay, yeah, I didn't know if there was anybody had a question about that before I moved on to the other stuff.
Yeah, I'll just go to the chat room. Is anybody here? Oh, yes, there is a question. Question from Z Proxy. He said, have you tried a VR headset or have you used a 360-degree cam yet?
Me? No. I'm not sure what he's asking as far as
when they've used a 360-degree camera, that's C Proxy and Stan Smith, the sky turns into the rainbow effect, and so they were just, they're just good things. They leave theirs going 24 hours a day.
Okay, I don't think I'm familiar with that. Of course, I've seen.
I can give you Dan Smith's channel, so you can look through some of them if you want.
Okay. But yeah. Anyway, as far as like footage we see from balloons or anything like that, looking down on the Earth, I don't think we would see the firmament necessarily because the sun and moon are in it, and as Chris will probably elaborate later, there's got to be some kind of layers going on because as the Earth and the sun are within the firmament, they still have to have their own lensing issues. So I don't think the firmament is necessarily simple, but I just think it, when we talk about the dome or whatever, it isn't just a dome. I think there's a lot more going on with it optically and magnetically. So if you want, I will go to, well, let me first, I guess, show my eclipse time lapse.
Yeah, sure. Brilliant.
Why isn't that playing? It's supposed to play. Oh, that was my still shot. Sorry. I guess I'll do this one and then I'll go find my time lapse. That's from the time lapse, but it's a still shot. And the reason I wanted to look at this is a little bit of a twist on what I was saying privately yesterday. You can imagine this light falling away as going over a sphere. Okay, so I can't rule out that it could be a spherical object in front of the sun. At first I was thinking, and the other things I'll show in a minute, that it had to be that there was nothing there. But I'm looking at the way the light falls away here and thinking that is just like a sphere. So just to keep that in your back pocket while I try to find the picture I actually wanted. Why isn't that showing up here? Let me see if I can. Okay, it's this one. Here's the time lapse. Okay, there, it's blown up. Yeah, this was what I shot on the eclipse. We had about 90% coverage where I was. It also had this night convenient line of spots acting like an hour hand. You can see it move like an hour hand a little bit. It takes all day for it to move usually, but this is what I had. It looks for all the world like the object in front of the sun is eating the sun and then going back, spitting it back out the other side. It also has an arc to it. It comes in from the top right and it exits from the top left. I'm not sure what that means. It would tend to, and I have to say, any of the drawings and models that the mainstream media were putting out didn't make sense either for the path of the moon's shadow. It just didn't, in a ball model, it should have been a smooth arc, but it wasn't. But this kind of a...
They didn't talk about the fact that the eclipse was going as far as Portugal either.
No.
They didn't really mention in the UK that much either.
Yeah, which is strange. People think it only happens in one spot, but the thing is that the size of this arc, it can't be very big. If I'm seeing an arc in my little window of view from anybody on the surface of the Earth can only see so far. And if we can see an arc, then how big can the Earth really be? And shouldn't, why is there an arc? Is it related to those sun arcs that are due to lensing? That's a possibility. It's also possible possible, if I'm wrong about the lensing, that it could be a smaller circular Earth. But I'm still sticking with the lensing for now. It would explain this better than any other model to have that double concave lens. So yeah, like I say, I think it works in anything. But so let me go on to, if I can find the picture I wanted.
Something you told us in the chat yesterday, like when you actually focus on it, or is that something you were going to do?
I should do that now that you reminded me, because I'll forget. I got the P900 just for this, and I noticed that it had a scene mode, and one of the scenes is for moon. And I took it out, and sure enough, if you aim the camera at the moon and you push OK when you got it in moon mode, it'll zoom in on it, set it in the frame nicely, and set the exposure and the focus and everything. And it's not infinity, by the way, which is the first curious thing. It doesn't require infinity focus to see the moon in focus. So the moon is not infinitely far away, which it should be at 230,000 miles. But anyway, it puts it in the frame at a certain size, okay? Now, when I did the eclipse, I noticed, well, even before that, I was practicing to make sure I'd get the eclipse right. Of course, we had terrible weather, but I used moon mode. I found out when I was just looking at sunspots before the eclipse that you can use moon mode, and it will do the same thing as if you're looking at the moon. It doesn't know what I'm looking at. I pointed it at the sun, and lo and behold, you push the OK button, and you get the same size disk in the frame, nicely focused and exposed, just like the moon. How can that be possible if they are so many orders of magnitude apart that we can't even imagine?
Paula, just repeat that bit again to everyone.
Okay. The camera has a moon mode, and it is based on what it expects the distance and size of the moon to be, and its brightness. Okay, it's all automatically programmed in, and I decided to try it on the sun, and it works just like you're looking at the moon, because it puts the sun at a certain size in the frame, the certain focus distance, it's not infinity, the certain exposure. It works just like you're looking at the moon. So how can that be possible if the sun and moon are so far apart? I don't see how that can be. So
that's amazing, isn't it? It's a bit shocking, because I don't think it was something you realised straight away. It's just something you realised that's what was happening, wasn't it?
Right.
Did you realise?
Yeah, I can't remember exactly what I was thinking when I thought, I'm going to try this on the sun because it's so handy, and it worked. And I'm like, that's curious. It shouldn't work. And that's another thing too. If even the moon, if it's a 250,000 miles away, you shouldn't be able to zoom on it like that. Are
you not shocked anymore, Paula?
Not really. No, but it was a pleasant surprise, I have to say, because I suspected it would work just because I don't think the sun and moon are far apart and a different size. And the camera would tell me that that was right, because it doesn't know I'm looking at the sun. And yet the same automatic program for the moon works exactly right for the sun. So,
which is crazy, isn't it?
Yeah. Very nicely crazy, though. I think it's one of those happy things.
The levels zoom in of what you can see at the edge of the firmament, what is in the firmament, no matter how thick the firmament is. That's never said there.
Yeah, it just can't be that far away. The sun,
and also, you noticed about the spots, because that goes into, because what you're affirming is Chris's work, and then also the spots, because obviously sun and moon put one out. The sun is a clock, and
yeah, and I have a couple of videos on that. But you can even see on this one, it was very nice, like I said before the eclipse, to have this nice row of spots acting like an hour hand. But that's how it moves. It also had some other curious movements. It wasn't strictly like an hour hand, but it always moves clockwise all the time. Now I had somebody trolling me in my chat, my comments on my YouTube, that this is due to me following it across the sky, that as the sun goes ahead, I'm moving my camera to track it, and that this accounts for it. But the more I thought about it, the more sure I was that if that were the case, then it should rotate counterclockwise.
Can I ask you a question, by the way? I saw it in one of my messages. Someone said, everybody's taking these pictures of the eclipses, but how come no one zoomed in to that eclipse? Instead of, like, everybody shot it like you wanted to catch the whole eclipse, but nobody has zoomed into that eclipse so you could see it really, like, full on in to see what it did there. Everybody's filmed them like this.
I could try to find... Yeah, let me try to find out. So I'm pretty sure I did zoom in at least a couple of points. So let me see if I can find that real quick.
Brilliant. I'm really sorry whoever put that question on one of the posts.
Yeah, I better not try to multitask or I won't find it.
Yes, okay. You can find that one in a minute if you like. And just wondering, the sun also gets a bit brighter in that. Is that due to the clouds or?
Yeah, that's the complication that made it a little more difficult to draw conclusions is those clouds, because that can also account for the apparent, that first picture I showed, let me go back to that for a second, that looks like a sphere. That could just be clouds, because that if I had a clear sky and it did that, then I would go, that could be a sphere in front of it, But since we had clouds, I can't really say. But let me see if I can find a zoom in.
I know what everybody's saying, but I sort of said privately, didn't I, when we spoke to you last night, that it just looks like it's going behind the sun. What I mean is, I didn't expect that, but it just looks like that shadow's going behind it.
Yeah, it's hard to say. Like I said, it even looks like it's going through it. I did find that picture.
Yeah.
Let me bring that into this folder.
But in Chris's work, the whole thing, it just hang on, I wrote it down because I'm not Chris. Hang on a second. He's basically saying it's a warping of the magnetic field, and of course, because the sun's in a toroidal field, and then basically it's the sun sort of going in on itself. So it's the sun interfering with itself.
Sorry, I'll have to stop sharing this for a second and then bring it back up. It wouldn't add that new picture to the list if I didn't do that. So, all right, let me share that again. And this is a zoom of the eclipse. Look how sharp that line is. Huh?
Yeah, there's a lot of like shine on that thing then.
Yeah, the inner thing, of course, is the eclipsing body or whatever.
Look, just down in that right corner, that's just the sky, or behind it looks exactly the same as the eclipse.
Yeah. But it's so tight that you really couldn't, you needed to back out. I wish I'd have gone over more, but I was trying to see the moon. I deliberately did that because I'm like, I want to find out, once I was sure I had enough pictures of the, zoomed out a little bit, because that's the whole purpose of the eclipse. But I wanted to try to see moon detail on. There's not a thing there, not even on the surface here, because if there's a little wobbling, that can be attributed to heat. It was a very hot day and clouds. But yeah, there's no detail here at all. I should have seen something. It's like Chris is going to say later about earthshine. At the full eclipse especially, there should have been some detail in the moon just from bouncing light off the earth. So there you go, a zoom. I knew I had one, so.
Cool, but that looks like there's a lot of light on it, doesn't it?
I'm sorry?
That looks like there's a lot of light on that bit there.
On here. So, but I will go into that a little bit more on some of my experiment. But before I do, let me go to this one. This is another one of those season things I forgot to show earlier. This is just a standard model. I don't need to spend a lot of time on it as far as how they expect to explain, like these are the equinoxes where the full face of the Earth is getting the sun. So the sun's pointing at the middle line. And then these two are the solstices, but I can show that again later. That's not a big deal as far as my what I wanted to talk about was. But let me trying to remember which. Oops, we don't need to necessarily see that one. This is I'll show you this in a group in a second. This is a rubber ball that I took a picture of today. It happened to have a lumpy surface. And so what I wanted to do was put this into the image processor and look at this space and see what I could see. And it's kind of surprising. Before I get there, this is a picture I took of the moon one night when there were clouds and made a pretty neat effect. But it looks, as far as anybody can tell, like a lump of clay there. It just does. I mean, it's got, there's light coming from over here, but it's the dark part. You can kind of see the rest of it because, if you look at the moon when there's no clouds and it's very dark and there's a very high contrast, it looks like there's nothing there. But this picture kind of gives the impression that there is something there. The moon is solid, but it could still be a projection. So we don't need to, we can speculate on that. But here, before I do the ones where I did the effects, here's a regular picture of the moon. This is a picture I took of when it was half lit up, and we got this pitch darkness over here. And then I put that into the processor and got that taco moon. There was just nothing over here. Okay,
nothing.
So that's why I wanted to take the same processing and do that to that rubber ball I took a picture of this morning to see if there's also nothing over there when it's dark, if it's just a contrast issue or a photographic issue, because we have to consider that. But it's interesting that it's got this a little bit of I don't know why exactly there's a dark line around it, because let me go back to the other picture. It's equally dark everywhere as far as we can tell, but there's the moon's reflection has got to produce some of that. So that's what I'm thinking, that this is brightness here, even though it takes this as white, it makes that black. I'm not sure. It could be just the image processor, but it's interesting more that, the white noise around it.
Because the reason that I was really so intrigued with this is that obviously with Chris's work, we've been looking at the eclipse with no moon there. But this is a moon phase, isn't it? This is just a moon phase. It's the same thing.
Right, just
on the other side.
Yeah. So now let me bring up this one that I showed you the other day. This is, I used GIMP for my image processor. This is an effect called Retinex, and there's different things you can do with that too. But the top is a picture of the sun with that line of spots on it that I took before the eclipse. And you can see these concentric rings, okay? Different levels of light, possibly different spectra. I'm not sure what's causing that, but we see this pattern of a kind of a gray middle, a white or pinkish line, pinkish yellow, kind of dark blue, and then these concentric circles. And over here is the eclipse at its maximum where I was. And we have these concentric circles, but they cut across like the moon isn't there. Okay? We have the same, little bit different light pattern, and not exactly sure why the difference is, but we have our gray middle, then a whitish edge, dark line, and then the concentric rings, but they cut across like the moon isn't there. And down below, I have my ceiling light, because it's an LED light and very evenly lit. So I thought that it would be a good comparison. And we have our concentric rings. They're not as obvious because it's not the same spectrum at all, or the same intensity, but same pattern you can see there. And this is me trying to hold a rubber ball in front of it and making a crescent. But what's different here is these lines, instead of going and cutting across, they follow the contour of my fingers and kind of silhouette the thing. They don't cut across here. And this is very well lit up, even though it's the only light in the room. Now, the complication I ran into today was, first of all, let me show you another set of 4 images. This is that rubber ball I mentioned earlier, 2 different shots of it, and 2 different attempts at a crescent, okay? And they all look, this looks very much like the crescent of the eclipse, and these look like the moon. Well, now let me put that processing on it. Let me get the right image here. And this is the surprise I got that I wasn't expecting. Look at this nothingness over here. This is my rubber ball. Nothing. Even though I know exactly that there is a ball there, a whole ball, and the background wasn't as black as I'd have preferred it to be to simulate the night sky. But we still got nothing over here. Absolutely nothing. It looks like the ball is shaped more like a football, American football, even though you can see kind of the seam running past a little bit, which is weird. And some of the, falling off over here, but it's a very abrupt drop off with this black around it. Now, how much of that is image processing, I don't know. And I did it over here too, just to show a couple of different images, but really not showing anything different. On the bottom, I have my eclipse with that same, actually it was a different ball that I used for the eclipse because I needed one I could destroy because I had to put a stick in it so I could get my fingers out of the way. And we can see here it's different because here we have this falling off of the light with the sphere, and you can see the sphere easily even though there's no other light in the room. Why don't we see the moon lit up like this? Because we have a very reflective Earth surface with the oceans and all, and there should be reflections showing us some moon detail, just like we got these speckles or just the light gradation, it's a gradient of different levels of light on here in different colors, but it's just a plain ordinary ball blocking out a light, and it's dark here, but it gets lighter as it goes down. And we did not see that with the eclipse. So that was the little bit of a twist from yesterday. I did not expect to see nothingness over here, but I did also, with the moon, we should see this, and we don't. With the eclipse, I mean. And that's pretty much, I think, all the pictures I had to show. I'm hoping he showed up.
So you're quite shocked that it doesn't show up, but it would mean though that because you've got two pictures that we would sometimes see other parts of the moon there, surely, but we never do when it's in its phases.
Right.
We see nothing. Right.
And I've also looked, just through the telescope without the camera, and you still don't see anything. Of course, the eye, the reason they do time exposures on star pictures is because your eye can't collect the light and store it in one spot in multiple layers, which it would have to do in order to see what a camera sees. That's why a camera can see things that we can't. But so you would expect the camera to pick up more, and it doesn't. It picks up nothing at all. And I'm having to think, as I'm not any expert, but I have some experience with photography and light. It is probably a contrast issue because the moon is always very bright against a very dark background, and it's always going to cause some optical illusions when you have that kind of a situation. And so we can't say that the nothingness means there's nothing there, because optically it's the same with this rubber ball. It's giving me the same problem, and it's because of contrast.
Top image is when you took the photo from the side, and the bottom image is when you took the image towards the light.
Yes. The top ones are, the top ones are a flashlight shining from the right, and you can see the hot spot too, which is another issue. The moon, the half moon I showed earlier, no hot spot. It should be bright. If we see this much of the moon, should see a bright spot right in the middle of that section, but we don't. We never see a hot spot.
Yeah, that's for sure.
But the moon is probably made of something weird if it is physical. There's various materials people have proposed as possibilities because of the craters and all being not impact craters, but more like electrical arcing craters. Or, as I was thinking earlier this summer, as I looked at the moon, it looks like something was bubbling and it froze, and that the dark parts of the moon are like black ice. And so who knows? And there's different levels of reflection on the moon too, or refractive capabilities, because there are little bright spots on the surface of the moon. Let me go get my real moon picture if I can find it now. Where did that go? There it is. We can see, first of all, where's the here's a almost direct half moon. The light's coming from here. Where's the hot spot? It's actually, if anything, maybe down here a bit, but the shadow isn't lining up. But on the moon's surface, you can see like there's a little brighter spot. There's little, sprinkles of like powdered sugar all over this thing. There's another one that's brighter than the rest. This has a medium brightness, and then these are dark. The seas, so-called, that's the sea of serenity, that's the sea of tranquility, and supposedly where Apollo went. But these look to me, if you were on Earth, you would say that was black ice, because you can kind of a little bit see some depth in it, and this would be the shore, or where the snow is or whatnot. But this kind of popped bubble appearance seems to me something that either when it formed, or from a biblical perspective, that the devastation of the flood probably had a lot to do with it, because the firmament separated the waters above from the waters below, and the waters above are still there, but who knows what happened electrical arcing wise or plasma wise that could have really done a lot of scarring on the moon. And we see that with a lot of streaks. Like here's a streak on the other half of the moon. There's more streaks coming out from the Tycho crater and the Copernicus craters. They've got lines radiating out. We see a lot of lines on the moon. So I'm thinking that there's had to do with either its formation or the flood or some kind of cataclysm that happened to it that changed its properties. So it's just a really curious thing, the moon. I have a moon video where I, did some more experiments at home a long time ago, and it, when it's full, looks like a disc, a flat disc that's just refracting light. But when it's not full, it looks like a ball. I don't know what to think.
A cookie?
I'm just puzzled by it. I don't know.
The series has got some pictures from me that I took with my iPhone, and it looks just like a cookie.
I like
presentation. The reason they came up was because Chris was saying he thought that it was more looking like a cookie with a flat back and the cookie shape on the front. Of course, I've got pictures showing it, but it's with my iPhone.
It's always using us and kind of the plane of inertia of its own field, of its own toroidal field. And we see the plane from below in that sense.
It would be nice to get a reliable, trustworthy magnetic picture of the moon, its magnetic field, not relying on NASA's so-called satellites and whatnot.
Our own tools, for once. Yeah, in that sense, data is everything.
Yeah, I think in the chat he's mentioned that 90 degrees angle to the Earth. Every one of those craters is at least 90 degrees to its surface. If it's a sphere, and it seems to be, all of them are 90 degrees. That means they're not impact at all. They're coming up from the surface and popping bubbles, or electrical arcing. I'm told that, you can't see it very well, but this one is one of the many that has a dot in the middle of it, a raised dot in the center. And I'm told that is a sign of plasma arcing, electrical arc with certain materials. Yeah.
It's their own effect. One is arcing as a mountain, the other one is kind of a bubble, what you see with a particular little small dot. What is then a mountain, and then the other one is the one with the what is it? Crater.
Right. Yeah. I could get a whole bunch of moon pictures if you want. I think I'm kind of done with this set. Okay, let me shut that one down.
You probably can connect many of the craters to its polarities.
Oh yeah, I'm sure there's electrical properties going. That's why I think it would be really interesting to get some kind of magnetic map of it.
Yeah.
So here we go, everybody. My home movies, my home slideshow. I guess I can just roll through these. I know I have some close-ups in here. You can see some of the streaks, but I want to get the other half of the moon. Well, here we can say one of those dots. This is one of the smaller ones, but there's a raised dot in the middle.
Yeah.
Let me go on. Here's some of the bright spots. What I call the powdered sugar sprinkling on it. I'm always thinking of food, tacos and sugar.
It's like you're looking into the universe as well.
Yep. Got a nice camera now. I have to do it. Before I was taking, some of these are going to be pictures I had before I had the P900. I was using my telescope and a cell phone. And it got pretty good results, but it was a royal pain to line up. But
Yeah.
there's a nice crater with a raised center and a shadow. I mean, this is classic light coming from here, and you can see it's brighter over here. But these look like pop bubbles. They just do.
The other ones, yeah, that's the other polarity.
Yeah.
One is crashing in, and the other one is crashing out.
Mm-hmm. They certainly don't look like impacts. And this, if anybody's curious, is the Appian Mountains, named after mountains in Italy, I understand.
That could be a big one.
Yeah, it's a crater of sorts. It's just kind of a half crater that, looks like it was covered over in time, which I don't know what to think of that, but moon history, we don't know very much.
Yeah, what lays on top of what? Huh?
Oh, there's showing this looks like a muskmelon or cantaloupe with there's the navel there and more food analogies, but it's got large streaks going out from it in every direction. That's the Tycho crater. This is the Copernicus, and it has more spidery, like an electrical discharge.
Yeah.
So we got two different kinds of streaking, and this one goes all the way around the moon, I think. It goes, you can follow it all the way up through the Sea of Serenity as far as you can see. It goes in both directions from there. And there's another one going this way. So really interesting stuff. But in spite of the fact that we've got all these dark spots, I mean, probably in area, I'd say close to the half to a third is the darker stuff. It still reflects light evenly, very evenly, like a flat disk. And yet it's a sphere. I don't know.
Yeah, it's somehow we see actually through it as well. So the kind of that the dark side of the darker part of it is actually the back side of it. We see both sides together.
Could be. But the thing that stops me completely from some of the theories is the surface shadows, because as I've said before, if we shine a light on a translucent ball, even though the light's coming from outside, it bounces around inside and comes back out. It looks like the light's coming from within, but it really isn't. It's kind of going through. And the problem is that even if you have that, you still, as long as light's coming from inside, I don't think you have surface shadows, and that's the problem. This was just a very yellow moon near the horizon that I took one night. But I got a pretty good shot of the full moon that one night. But it puzzles me. Sorry?
Darker spots are connectable with the lighter spots.
Yeah, I don't know. It seems kind of random as far as, like we had a string of them here, a little bit of a pattern.
In a way of that the light spot in the front is actually, and then you get the dark spot at the back. And
Yeah.
that's the reflection of the light spot itself.
Yeah, it's definitely brighter here, but here again at night, it's really a little harder to tell if there's clouds or haze. And that I do have pictures where it's very dark up here, and I know that was clouds that night. But so there's too many variables, I can't, like here's the clouds, these very dark spots. I knew these were clouds because they moved across as I was watching.
Can I say something?
Sure.
When you say that, don't you think it's just incredible when you're saying that the clouds cover the moon?
Yeah.
Like that.
Yeah. From 250,000 miles away, and then the clouds getting away.
Yeah.
So it's just, the thing puzzles me. Oh, that's a blurry one. You don't want to see that one. There's the Tycho crater, and there's one of those big streaks. It's like, what is up with those? I hope I have in this set one of the Copernicus crater with the spidery discharge. Oh, you can see it pretty good there. Electrical arcing all over the place on that one. And here's a little bit of the rough surface we never see on the eclipse. I mean, it's bumpy. And I do know I don't have a good, someday I want to make a good time lapse of the moon, but it's hard for me to do that because I'm not a night owl and I'd have to watch it all night. But I do know from mine and other people's footage that the moon not only turns this way and that way, like clockwise, counterclockwise, it also rotates that way a little bit too. Sometimes you see more of the bottom, sometimes a little less, that this crater would be down here. So it's got movement in at least 2 axes. And so it's just the same thing the sun does. It seems to have also those kind of, both kind of clockwise and rolling toward and away movements. So the movements are really complicated. I'm not quite sure what to think of it. And that's not enhanced, by the way. The P900 will let you put color on the moon, and I had to shut that off. But this is an actual what I saw one night. It's very spectacular.
At the horizon.
Yeah, it was, and it changed. If I focused very tight on it, the color went away completely.
Okay.
And I would zoom back out and it would be yellowish red, kind of orange.
Weird.
Yeah, I don't know what to think of that. I think that was a zoom of the same night. I'm not sure. I'd have to look at the data, but very striking color. And I think in one of these I could see, there you see between these two, on the right side, the terminator line moves a little bit. I had 2 different nights. I could see it rotates a little bit. They're telling us it's exact, and but it varies. It goes back and forth, and we don't always see the same amount. So anyway, I thought that was interesting. I took a lot of moon pictures. I had this nice camera. I thought I'd better.
I think it's a bit of an art though, because I've got a cool pics, and someone said just point and fire. It's not like that. It's really, you have to get the settings right, everything.
Yeah,
and that's just on a cool pic.
Yeah, even the point and shoot, if you're just shooting people or, just average scenery, it's fine. It does a great job. But if you want to do anything else, especially since the moon and the sun are moving, if you zoom right in, it will move across your field of view. And, you have to move your camera unless you have an equatorial mount, which costs almost as much as a camera. But someday I'll get one. But anyway,
it's expensive, isn't it?
The equatorial mount? Or the camera?
Yeah, everything's expensive.
Yeah, everything.
Yeah.
But I think you've probably seen enough of the moon. I don't know what else to say about it, but it doesn't make any sense to me.
You said that you've got a couple of videos. Could we watch a couple of your time lapses?
Okay, let me see. That would be more on the sun. I do have some moon. You want to see moon or sun?
Yeah, sure. We've also got Karen B with us. Hello, Karen B.
Hello. Sorry,
Hello.
a little bit later than I thought today. So I'm a little behind on what you guys are talking about.
Oh.
Sorry, you want me to start over?
No.
Yeah. Yeah, go for it, because it's for people to understand. Catch up with Karen if you want.
Well, just real briefly, because I don't want to dig out all those pictures again, but I was talking about a couple of things. One is the movement of the sun, and how the only way to explain the fact that if, say, you're on the equator, the sun will rise directly east, go 90 degrees over your head, and go directly west. But if you're in any distance past the tropics, you'll never see it go 90 degrees. It will go east and west. Even at the solstice in the northern hemisphere, it went north of east, north of west. But when it was overhead, it was not 90 degrees. It was 70 degrees. So it was tilted toward the equator. And the same thing happens in the southern hemisphere. The sun's arc will tilt toward the equator. Well, how does that happen every day, every time zone, that same movement? How can we explain that? And I decided that it has to be some kind of lensing, and that the lens shape must be a double concave lens. And so I'll let you, later you can see all the pictures I showed for explaining why I came to that conclusion, but it works in every model of the Earth and the cosmos, every model, because if it's a ball Earth, whether you're geo or heliocentric, if the Earth and the sun both have some kind of lensing around it, which could be magnetic, could be optical, between the two of them, you get that double concave shape. And with a flat circular Earth, if the circular flat disk Earth is surrounded by a toroid or donut kind of a field, and so is the sun, then between them, you have a continuous double concave lens. And the same thing with the square Earth. If the sun is going east and west like this, and you have this shape of lensing over top of the Earth's surface and this shape around the sun, you still have your double concave lens. So no matter what model you have, as long as you have those two different densities of lensing around each body and a space between that is not lens, then you get that double concave shape, and it accounts for the sun's angling toward the equator. So that was one thing. The other thing was when I photo process the eclipse or the moon by itself, we all noticed how, lots of people have noticed how on the dark part of the moon, you don't see anything. There's no detail. I even had a close-up during the eclipse that there's just nothing there. And we start to wonder if there was anything there during the eclipse, and what happens to the half of the moon you don't see, or whatever portion you don't see on a regular moon phase. But I got some rubber balls and a flashlight in a dark room and shined the light on it from the side and got the half moon, looked for all the world like a half moon, and image processed it, and I had the same result. There's nothing in the dark part. So there's a contrast issue going on optically that is kind of fooling us a little bit of an optical illusion. But when I put I'm sorry?
I'm saying that's really good that you did that. I was mentioning that yesterday on Globebusters because everybody keeps using that as proof that there's no moon, but nobody's vetting that process.
Right. I was trying to think of a way to duplicate that. And so I got the rubber ball, and then I also put it up in front of a light that I have in my room. I have an LED round light that's very even, the light coming out, and you can change the spectrum of it, the warmth of the light. But I held the ball in front of it and made a crescent, just like at the peak of the eclipse where I was, and took some pictures of it. And the light coming around it did not behave when I image process it and change the change the contrast, did not behave the same way as the eclipse. So there is a difference there, and yet, so we can't say for sure whether there is a spherical physical object passing in front of the sun or not, but we can't rule it out either, I don't think. But there's a lot of things that we need to, repeat our experiments and try to figure that out. So
I see what you're saying about all that, but wouldn't we sometimes just see other parts of the moon then?
You would think so. And like I said, there should be a bumpy surface. The moon should not, during the eclipse, should not have had such a crisp edge to it. Especially, and Karen missed this part where I was talking about the focus difference in the camera, because the P900 has scene mode, and in that, one of the scenes is moon. And what you do is you just line it up and press OK, and it has it perfectly framed and focused and exposed. Well, you can do the same thing, and I did that for the eclipse with the sun. I set it on moon mode, and I took all of my eclipse pictures that way. It was perfect. It didn't know it wasn't looking at the moon. It considered it to be the same distance. The focal length, everything was the same. It is not infinity for either one of them. So if I can shoot the moon and the sun with the same program, then what does that tell us about the moon and the sun? They got to be the same distance pretty much, very close. And since it's not infinity, because a photographer could say, well, if that infinity focus, you will get that, they would both be the same, but they're not infinity, neither one of them. You can go focus past them. So I thought that's interesting that you could use moon mode on it, and it was a very handy setting. I every time I needed to take a picture of the eclipse at a different stage, I just hit moon mode, and there I was. So, and it made it very consistent size-wise too. I did zoom in a few times, but so that's pretty much what I was talking about, and I showed a bunch of different pictures of image processing.
Maybe that means that everybody with a P900 camera now has to set the sun on the moon setting, and then see that it's
But
Karen-
was that with or without a filter?
With.
Okay.
I mean, I wouldn't dare to point it at the sun without a filter. So
Yeah, I figured. I just wanted to make sure.
yeah, I
Can
actually.
I just say as well, by the way, that it's really nice having two ladies on that do this kind of research and videos and films and that, because it's usually the men.
Yeah, they get all kinds of free time. We're always working, aren't we? I had an opportunity there. So, now, did you want me to? Oh, I'm sorry.
Wonderful to, it's finally wonderful to see the women as well. They have the brains as well. They're not stupid.
No,
Thank
we're
you.
not serious. Thank you.
We really appreciate that because, we're always told we're just emotional and we can't brain this stuff. So we have a witness.
Yeah, you proved it wrong.
Yeah,
you did that very well. Thanks a lot,
Well,
Christian.
thank you. Did you still want a video of the moon or anything? I know I have
Maybe
some.
we've got Karen B on here as well, and second hangout with you, Karen B. Maybe Karen B wants to show us some of her stuff as well.
That would be cool. I think I've seen a little bit of it that looked really interesting. I'm trying to see if it's going to actually play my video. Oh, that's an older one. Sorry. I need to find one with the P900 because that one's out of focus.
Artist in the chat room says, ladies' night.
That's right. I probably should have tried to find out ahead of time. It would be easier to find ones more recent because I can't tell. I'd have to look at the dates and I have to open each one up and go, what are the properties and try to find them.
Well, Karen, have you got any of your stuff ready while Christian's getting her stuff ready?
Well, what kind of stuff? Just Eclipse stuff in particular? Or?
Maybe, or anything that's grabbed your whatever it is, like Paula's worked these things out herself and explained it to us today.
Yeah, I'm glad she did that, and I was actually planning on doing something like that myself, although I haven't really gotten the chance to do it. But I haven't done anything like that yet. But I have planned on it. I feel really sort of ill-prepared right now. Let me see here.
That's okay. This is live research, guys. It's perfect.
You know what, Karen? I don't think I have any good videos of the moon with my camera yet. I've taken all still shots. I'm sorry about that. I can show you one of my older ones. They're just not as good. I guess that'll have to do.
There's two Karens here, by the way. There's Karen B and there's Karen P.
Okay, sorry about that. I do have
one. Oh, that's okay. Don't worry about it.
Let me see if I can make that any bigger. I don't know if that'll matter. Can you see that? This is with my telescope and my cell phone. I don't know if looks like I'm presenting, but let me just play that. The audio doesn't matter. I'll turn it off anyway because it's usually just my air conditioner sound. Nobody wants to hear that. But that's how the moon moves when you're just holding still and letting it run, move past you. Of course, that was a bump, but this is it's just a 3.5-inch diameter Meade telescope, and I forget what magnification of eyepiece I had, but I think it was around a 9mm, and then I would use the digital zoom on the phone and got pretty decent pictures with it.
That's not bad.
Yeah, it did surprisingly well. It was just such a pain to set up because I think the scope actually came with an equatorial mount that it's bolted to. You can't even take it off, and it stopped working. It lost its mind. It won't track anymore. So I have to do it manually. And finding the moon and then trying to track it, I at least had a motor control that a hand unit that I could move little bits at a time, but it was very jerky, and every time it would move, it would wobble. And So that was kind of annoying, and that blue around there is just chromatic aberration. Like, due to the cell phone, it's not something I could, that I would see with the naked eye. But
So
I will
your
have
cell
to.
phone, colours then. The cell phone makes the
Sorry?
colours then.
Yeah,
The cell
Because
phone makes the colours.
yeah, it just has a fairly cheap lens. It's still surprisingly good, and it's a 16 megapixel camera, which, in the phone, which rivals the P900 for density, but of course the optics are not anywhere near the same, and all the zooming here is mostly done by the telescope. So, but it worked for me up until I finally got the camera. I've been wanting that for a couple of years. Since it came out, I wanted it.
I've got a question here for you. This is a bit more about Frankie asked to show about the crescent shadows on the floor. Do some of that as well, or was that just Chris?
No, I didn't do that one. I think that was just Chris.
Yeah, that was just Chris. I thought it was. Yeah, amazing though.
Yeah, this is how fast the moon moves when you're tied in on it so that you can't see the whole thing in the frame. It's surprisingly quick. If you turn away for a minute, then it's gone, and you have to find it again with the scope, which, as I said, is a royal pain. With
Can
the
I tell you
P900,
one thing I saw? Well, one thing I saw, it was when it happens twice a month when the moon does its equinox. That this person told me at a certain time this thing would happen. I looked out the window. I mean, we get a lot of cloud, but these two times we didn't. And at this certain time, I think the first one was about 10:30, the next one was 12:30. The moon came in, and it came north. It was going slightly east, but it was going north. And then an hour and a half later, it went west. And what it did in that hour, it pulled all the stars with it. All the stars came. There was Orion's belt. They all moved, but I didn't look at the other part of the sky to see whether all the stars were going. Just that everything I couldn't believe it. The moon was moving really fast. I could put my finger on the window and watch the moon pass my finger in seconds. And all these stars were moving. And I saw that twice. Like that.
Yeah, I wish, if I was more of a night owl, I could catch some more of be able to watch it at length, Plus, we get an awful lot of clouds and chemtrails here. I would have to be, I'm told by people, like sometimes my husband has a late night and comes home at 2 or 3 in the morning. And he says, "Oh, you should be up now. It's when the stars are out and you can see everything so clearly. It's the time of day I'm least likely to be able to see it."
Karen, have you seen anything like that then?
Like what you just described?
Yeah, when the moon, all the stars came with the moon, and the moon was moving really fast, but it did almost like a heartbeat. It came in, went up, and then went off.
No, I have not witnessed that. What time of year was that?
That was January, in those 2 equinoxes of the moon. So obviously twice a month, the moon does this and drags the stars around with it.
By equinox, do you mean when it's half moon?
I was going to say, was it?
Yeah, the moon does it twice a month. And on those days, at this certain time, it just, somebody in my group gave me the times. I'd have to go and find it myself. But twice a month this happens. And I wonder, this is how the stars go round in the sky. This is why they changed that little bit with the seasons. Because the moon's doing it.
Twice a month, so what is it, like first quarter and last quarter, or moon phase? Do you remember what phase the moon was?
Ooh, it wasn't a full, oh golly, it wasn't a full moon, no. I can't remember exactly now. This was January, wasn't it?
It would be
I was
twice.
just so shocked.
I'm sorry.
No, it's more than that.
Oh,
the
really?
moon, doesn't it, Siri? Siri, explain it.
Explain what?
The moon does these equinoxes each month.
Equinox? It crosses the equinox, you mean?
Yeah.
Yeah, I'm not really into the moon or the sky itself. I'm more into working the land.
So you're talking about when the sun, because the sun does go between the tropics, you mean?
Yeah.
Because the equinox is.
Okay, it might be that then. But I thought it was to do. Yeah, maybe it's that then.
Gonna
Maybe
go
it's
to
just
the
the
moon
tropics. I'm
crossing.
sorry.
When it's hemispheres, you mean?
Yeah, it does it twice a month. Remember what Dave Marsh was telling you, that it does it 13 times a year.
Yeah, if you go by the moon months, it's 13 months.
Yeah,
And
anyway, well, no one's seen it, but I'll try and see if I can get these dates for maybe the next one, because we don't see, we get so much cloud. We're lucky when we see these things. Well, I did that night, but I couldn't record it. It wouldn't have made any difference, really. You'd have to see it, I think, because it would have just been a bit of film with the stars. And I just, yeah. I just had my camera then. I just had my mobile phone, so it wouldn't have been the same. But anyway, we're watching Bad Christian's moon. But you do agree the moon moves really fast sometimes.
Yeah, that's why, it'd be ideal to have an equatorial mount, but otherwise you have to keep your eye on it when you're tight zoomed in like that. But it's nice. I've some of the footage that I've had, if you just didn't know better, if I've zoomed in as tight as I can and let the moon go past, you would think you're watching Apollo footage of the LEM going over the surface. I mean, you can do that from Earth easily. You can reproduce that same magnification of the moon.
well,
So
if you think about it, I mean, you're just doing that with like a home telescope. Think about the telescopes in the observatories.
right. Exactly. And they've got their scopes up in the desert or on a mountain where they don't have, near the atmospheric interference that we have. I mean, I'm in the Ohio Valley. There's lots of vegetation and moisture in the air, high humidity, lots of clouds. And, I'm not likely to be out in the winter, so when it would be drier and clearer. But still, we do get lucky now and then, and that's when I go outside and feed the mosquitoes, as I call it. They're nasty.
Do you see the sun and moon doing different things? Like sometimes I've watched it. I mean, I did more of that research on that last year. But sometimes the sun came in slow, went off fast, came in fast, went off slow, came in slow, went off slow. You know what I mean? There's just different patterns. Do you see the same thing? Or do you just see the same thing every day?
I don't know that I have enough days in a row where I can see it rise and go all the way across the sky. I have a better view of the east than the west where I live. And so I can't really say for sure, but I do have a sundial. I have two of them, homemade sundials. One is horizontal and one is, up at an angle at our latitude. And they work. The sun moves 15 degrees per hour consistently. And I mean, there have been many days when we had enough of the sun to see a shadow that I followed it all day long, and it was precisely on the numbers. So I can't vouch for a change of speed when I look at the shadow on a sundial. I think that is a more accurate way to watch it anyway, because a lot of things can change perception. But if you've got one light casting a shadow and you watch the shadow, it pretty well tells you how fast it's moving. I don't know. It's just kind of what I think off the top of my head.
A little bit different here because we're sort of more north, aren't we? We see like different stars. I see nearly all the stars going around me. I know in America, in some places, the Big Dipper bends down over there and it goes out of sight. It doesn't do that for me. It's always in sight.
And right now, it's very low in the kind of northeast. Well, it's very close to north because I don't know if anybody in the chat doesn't know, if you follow the last two stars of the Big Dipper, the end of the Dipper part, and make a line from that, it points to Polaris. So it's always going to be going around Polaris. Of course, that Polaris is the end of the handle of the Little Dipper. But these right now are fairly low in the sky. I think they're actually higher in the winter, if I remember, but I'll have to check again this winter.
Yeah, well, for me, it's lower. The sun's lower in the winter.
Right. I mean, I'm about just under the 40th latitude, so 40 degrees latitude. So
I'm at 35.
Okay, it shouldn't be that much different, but it seems fairly low to me right now. I don't know.
Yeah, it is right now. I would agree with that.
But not that I go out much in the winter, so I couldn't tell you for sure.
But then as a flat earther, you always look at things differently, don't you now? So, you know, even me, I go out and I go, look at that. What's that doing? Why is that there?
Yeah. And I've tried, even with the P900, to zoom in on any star. I have enough trouble looking at the planets. I've seen the stripes of Jupiter. I've seen the rings of Saturn with my scope. But it's very hard to zoom in on a star. You really can't. You just still get a bright point, no matter how much you zoom.
Have you watched those tutorials of how to do the manual focus on the P900? Because it's not like a normal camera.
Yeah, I tried that a few times, especially with Jupiter, because it's a lot easier to see than the rings of Saturn. And I couldn't get it to do that. I would shine the light on the camera and say, focus lock or exposure lock, I mean, and then zoom in on it. I couldn't get the stripes to show up on the camera. I don't know why that's not working for me.
I didn't get the stripes to show up, but I have gotten Jupiter and its moons. One day I got all 4 moons.
Did you?
Mm-hmm.
I have some older footage with my old camcorder. It only has 1 megapixel, but I got some decent pictures of Jupiter's moons. And it seems like almost every time I look at it, I get a good shot of it. The moons are all in a very nice line. And they seem to have a terminator line on them where the light's coming only from Jupiter, not the sun.
I haven't, I can't say I've noticed that detail.
Yeah, next time you look at it, check that out. It seems if you can zoom in on one of the alleged moons of Jupiter, they seem to have their light coming from Jupiter and have a shadow on the backside of them. I don't know, maybe I'm just seeing things, but some of the footage I'd have to look up. But
it could be that I'm gonna now you got me curious. Next time I am in the opportunity to record Jupiter, I'm gonna look for that.
Could I just say as well that Yudit has joined the Hangout, and Yudit is another lady who takes loads of pictures of the sun and moon, aren't you, Yudit? And Yudit is in Israel.
Mm-hmm. Hello, Yudit.
hello.
Yeah, I have some video of the sun and the moon that if you guys want me to share, I can do
Sure,
that.
I can turn off the home video here.
Thank you a lot, Bad Christian.
You're very welcome.
Good evening, everyone. Karen.
Hello.
Hello, Yudit.
Okay, let me share.
Ladies on here. Two lady researchers, Yudit.
Yes, wonderful, wonderful.
Yudit has a P900.
Awesome.
Yeah, it's a lot of fun. I love that camera.
I do too. And I've already got 500 pictures of the moon and sun. It's like, well, now what do I do?
I know. I started having to delete some. I was like, okay, well, I'm just going to have to delete some of these because it's just too much.
So you're looking for sun pictures, is it? Because I stopped sharing that, I think. Why is that still playing?
That's me.
No, that's Karen playing.
It's like mine. I thought, wait a minute, I thought I shut that window.
I don't know.
Monkey's up now.
Looks familiar, doesn't it?
Yeah. Let me see here. This is actually kind of like, I like looking at the full moon, but I really like seeing it at like the 95% area, because then you get that crater detail. Those are like, oops, sorry, I turned my volume down.
Yeah, I have a picture I have a little booklet called the Sky Observer's Guide from back in the 60s, and it had a photo in it where they took 2 half-moon pictures and put them together to make one full moon with detail. So, because you get the shadows, like you were saying, and So that's one way to do it. Only I never seem to get the other half because it seems to only happen either in bad weather or time of night I'm not up.
Yeah.
Karen, do you stay up long hours doing this, or do you go to bed at a reasonable time?
Well, I've got 2 children that are in school, so now that summer's over, I'm gonna have to start going to bed earlier. But yeah, or I just have to keep my eye on the moon, and when it's, you know, high in the sky a little earlier in the evening, I try to get out there and take pictures. Or sometimes I'll go out there late.
So sometimes when you take the moon, it's quite brownie-like, and sometimes when you take pictures, it's quite grey-like. Because someone's put that in the chat room, Robbie. Karen, in January of this year, the moon was waning and looked very dirty brown towards the end, but it was moving really fast, and I went to get my camera and it had gone.
I do know when I showed that one yellow, orange, reddish kind of moon that it was very close to the horizon at the time, and when I zoomed in tight on it, the color went away, which I can't figure out, but it can be atmospheric conditions. We just don't know.
Yeah, I think a lot of it has to do with atmospheric conditions, because I mean, I've gone out there and the moon was straight up green.
Yeah, I agree.
I haven't seen green yet.
I think it was because of there were some fires going on.
Green.
Yeah, if there's well, in my area, if there's forest fires going on, yeah, the moon will turn green. It's bizarre.
Huh. Well, I'm happy we don't have many forest fires, but at the same time, that would be cool to see.
It is cool to see, yeah.
Yeah, it's so moist here that we rarely have a problem like that with wildfires.
Great video. I said it's a great video.
Thank you. Most of what I do is looking at the sun, though. I definitely look at the sun a lot more than I look at the moon. It's just probably more out of convenience than anything else, because I love looking at the moon.
I do too. I don't know why. The sun has been a recent thing for me, just mainly because of interest of the eclipse. And while I was practicing, you know, making sure I knew how to use the camera before the eclipse came, I didn't want to be totally fumbling with it. I noticed the spots, and I started tracking them all summer long and seeing how they moved. And it's very clockwise motion. We never see it do what NASA says.
No,
Yeah.
in fact, in the group that I started, the sun tracking group, that's what we've been doing. We've been taking a lot of photographs, like hourly photographs, just starting in the morning and just hourly taking pictures of the moon and watching the movement of the sunspots in the moon. And, you know, they're moving clockwise for me and counterclockwise for other people, like our one guy that we've got in Brazil who does it. And you can watch, you know, you can watch it spin, you know, like a wheel, literally like a wheel in the sky. That's what it's doing.
I think
remember, I know in Mexico, his eclipse, his name's Robert Kidner, his eclipse. So your eclipse went from left to right, sorry, from right to left. His went from left to right.
that would make sense. Depending, if you say he was in the southern hemisphere.
Yeah, he's Mexico.
Okay. Oh, well, that's in the tropics. That's in the north. They're within Mexico. At least most of it, I think, is within the Tropic of Cancer. So,
You can find his video if you like.
sure, or just drop a link. I'll look at it later. But
Okay, then I can do that to you in a message.
yeah, no need to go get it now. But that's curious, because it shouldn't be possible north of the Tropic of Cancer, you should have to look the same way to see the sun. Of course, like I said, as far as where it rises and sets, it goes way farther north than it should. For where I am, the sun should never go directly east. It should always be south of east, south of west, but it's gone northeast and northwest at the solstice. And it has to be lensing. That's all I could figure, because then when it's not as lensed, when it's at its zenith, then it's where I would expect, which is, 20 degrees
Well,
south.
I have to say that we have had some quite cloudy weather this whole summer, although it's warm at the moment. But last year, when I was really tracking what was going on outside my window, the moon was in my window shot for masses of time. And this summer it hasn't been, even though there's been clouds, so I can't tell all the time. But, oh, there's the moon, either way, left of the window, right of the window, coming in, whatever. But this year, different place. When I've seen it, it's just not anymore. But anyway.
That was a good shot of the spot.
Maybe it's
Yeah.
Yudit, you want to show a couple of your pictures then? Yudit? Yeah, she takes a little while to come on because she's got to do this and that, and then she comes on. Yudit?
Yes, Karen.
Yudit, do you want to show us a couple of your pictures?
Oh, I don't know how to do this. I don't know.
Well, if you put them in the chat room, Ceres will show them. Can you put them in the chat room?
Karen, I am a little bit dyslexic on the computer.
I'll do it. Ceres, are you there?
I'm here.
Ceres, I put my biscuit pictures in to the messenger. Do you want to show everybody my biscuit pictures? Bear with us a moment while Ceres picks up the biscuit pictures.
If you want to see something that I caught recently, I know you were mentioning a tracker. I purchased a tracker. It's not an equatorial tracker because those things are like thousands of dollars. But I did purchase I have a polar tracker that you have to line up to Polaris, which is almost impossible to do during the daytime. So I try to cheat and use Stellarium, and then I kind of have to check it and redo it and check it and redo it. But I was able to line up my tracker well enough to get a time lapse of the sun that lasted, it was a 25-minute time lapse, just a standard time lapse on the P900. But it kept it in frame and it showed really unusual movements of the sun. I thought it was pretty interesting.
Okay.
Anyways, this is it. It's just a 10-second clip, but the tracker has a really smooth movement. I did a time lapse of the clouds, and so you can see the trees, and so you can see that the tracker does have a smooth movement. It's not jerky at all. I bought the tripod that goes with it, which is really heavy. So check out how the sun looks on a time lapse. It's pretty cool.
Okay. Huh. Huh. And that spot isn't moving much, is it?
No,
it's moving a little.
Well, it's just a 25-minute time lapse.
Oh, okay.
It's not going to move a lot. But for me, the most interesting part was the sun kind of bouncing around. It's bouncing up and down, side to side, up and down.
Yeah, that is. See, I wouldn't know that.
Yeah,
right.
Towards the end, it starts to go out of frame, but I mean, and I did a few of them, and this was my best one.
Paul, Bad Christian was saying that, it was me, I flicked the camera then. Maybe it wasn't you then. It was it moving.
I'll show you another one. This one didn't stay in frame as long, but I got the same movement every time.
Wow.
and it starts to go down. But the movement, I mean, it's just meant to follow the line through the sky, just straight across. I mean, it seems rather strange that the sun's going up and down like that.
Yeah.
Kind of dynamic sky, and where you see the light through the waves waving.
Yeah, Karen, it was waving to you.
That's what it looks like, right? Let's see if I have another one. I'd like to try to do more of these, but man, it is so hard to line up that tracker during the day.
You know what you could do? I know not everybody has a sundial, but sundials only work if they're pointed toward true north, which is Polaris. And what you do is you get the sundial already, and then you wait till you go to timeanddate.com and check for solar noon. And when it's solar noon, the sundial should point directly at 12 on the markings.
Yeah, you know, I have a sundial compass that I use.
Oh, okay.
It does that for me. I should do that. That's a good idea. I brought it with me for the eclipse, but the eclipse happened, I think, after. No, it was before, during, and after.
Explain, please, sundial.
Sundial. Let me see if I can get a picture of mine. I have one somewhere. It's just basically using a shadow. I'm sorry?
After that, my chocolate chip cookie pictures up. Series will go through them just to show you that this is what it looks like through the phone. It looks like a chocolate chip cookie.
Yeah, I see that lighter shadow there.
And that's with my iPhone.
Huh.
Wow.
I just changed the color a bit to try and show, because obviously it's dark, but I did capture the dark part of the moon. So when we looked at your pictures and there was nothing there, there is something there this time.
Yeah, that seems pretty clear. And I know I want to clarify, because some people say, why didn't we see the dark side of the moon? Well, we're never going to see the dark side of the moon. What we mean is the side that is the new moon that's normally dark. You know, we're not going to see the back side of the moon, even during an eclipse. Just, you know, I've seen people try to say that, but yeah, that's...
But again, with an iPhone, it either does take them or it doesn't. It's brilliant in the daytime. It's not very good at night, and usually just picks the moon up as a bright light. I can't, you know, on the phone to do any better than that. But I think because there was only a little bit of the moon showing, and I could see, it must have been quite a light night or whatever it was. I could see the dark. Whereas on all the pictures we've been showing around the eclipse, there's no dark part.
And I think that's the autofocus, whatever it's set to, is picking up more of the shadow than most, you know, like a higher end camera. I'd have to, you know, the problem with the eclipse is you don't think about those things. You just want to get every shot of the movement. And when I zoomed in, I should have done manual exposure and played with it, you know, did an over under and bracketed the shot. So, but I didn't think about that. And how many times an eclipse happened? Well, 7 years from now, if I'm still even caring about any of that, it'll come right over my house, which, yeah, I'm like, oh man, 7 years.
Are you in the path of totality for that one?
Yep.
Awesome.
Yeah, we got 90% this time. We'll get 100 next time.
Yeah, my house wasn't quite in totality for this last one, but I had to drive 2 hours and I was able to get right in the center.
Wow. That would be something to see.
Didn't you just get your camera before the eclipse? Is that what you said?
I'm sorry?
So you got your P900 just before the eclipse. So, you know, you're obviously learning fast.
Yeah, I got it a few weeks before. So I had time to play with it, but I didn't think of that when the time came. You know, I had other devices I was trying to get working and they weren't working, and then the clouds rolled in and I was frustrated. But so I was just happy to get any shots. I have a sundial picture if you just wanted to see it.
Yeah, and afterwards I'll put some of her pictures up. Now.
Okay. These are the two different styles of sundials. This one is the good one that's horizontal that my husband made for me, that has these angles change every time because it's not compensating for the latitude like this one is when I angled this up at my latitude. And I just put a pin in the middle. You know, this is just a straightened up paper clip, and stuck it in the middle of this round piece of wood I found, and I marked it off 15 degrees. And then I went to solar noon. I went out and lined up the shadow. This is the solar noon here. And I'm using my mouse on the wrong screen. Sorry. This is the solar noon right here. So it's pointing at solar 1 o'clock, which here was 2:45 because daylight savings time plus the clock time doesn't match solar time. So that's pointing right at 1. So this is an hour past solar noon, and that one's pointing toward 1. I had the numbers marked on that one. So they both work, both styles, but that's what a sundial is. And if you don't mind, I do have a short video ready for sunspot movement. Kind of a little bit of a time lapse. Let me share this screen. Let's see. I hope I don't make my browser crash. Sometimes when I share, that's what happens. There we go. It's not exactly a time lapse. It is something I put in one of my videos, and I put the time of day because I tracked it all day long, and I put crosshairs where it began. Now this is where it ended actually, but if I play it, it goes. From here, I think it starts and goes back to the beginning where it started. Yeah, there's where it started, 7:52 a.m. And then through the day, it goes around like this, and but it also moves. See this way? That first dot has moved this way also. See it rotate?
Spirals.
Yeah, it's like a
Spirals,
spiral
yeah.
or a Fibonacci or something. Yeah.
Mm-hmm.
And it wind up from that many hours, from 7 whatever it was to 18. I used the 24-hour clock just for convenience, and it right on the crosshairs where this stop began. So it went from here and moved laterally and went back to exactly that spot. I couldn't believe how it lined up exactly. But I've never seen it move counterclockwise. So anyway, I thought that was interesting.
I got something kind of like that I do if you want to see it.
Sure.
It's similar to what
Sure,
you're doing.
I'll present you
now. Mine is like what I did is I took some of my pictures into Photoshop, and then I made this this like protractor sort of deal that I lay over the sun, and then I just kind of make an animated GIF out of it, and it shows movement there. This isn't me. This is another guy's pictures, but I've been doing it to everybody's pictures. But you can see that it kind of spirals around and then also in a little bit. And I think I did another one. If I can.
Yeah, and then having actually a 24-hour cycle or several 24-hour cycles available throughout the Earth. I mean, the light is all over the world in that sense, and that you can track the actual alignment of the sunspots indeed for a whole cycle. You can actually see the whole circle going in that sense, or several.
That's a good idea to put. I only had a simple crosshair, but that's a really good idea. Give you more precise, observation of it. of the movement.
Yeah, and then I took the I made different size triangles, so like it's 24 hours, and then there's quarter hours and half hours. I kind of stole the idea from another guy in the group who made one, but his graphics were kind of going into the sun, so it was kind of blocking the sunspots if they get to the outer edge. So I just made this one kind of still leaves more of the sun, face of the sun visible. So I haven't done too many of these, but I just started doing them. But I'm gonna have a whole bunch of these that are gonna show all kinds of movements of the sunspots and how they rotate and spiral at the same time, which is, you know, contrary to what NASA says. You know, they show that video. They had that high definition video that they put out when that major sunspot showed up, and what did they say? They said the sunspot was like 75,000 miles wide, and then it shows it moving, their animation that's going around this way horizontally, and they totally ignored the spiral movement. All they did was show this to kind of give you the illusion that you're looking at it from the Earth, you know, rotating around the sun, and they just completely disregard that spiral movement in their video.
They do that a lot. Just hope you won't notice.
Yeah, they just leave it out.
If I might, somebody mentioned in the chat something I forgot to show of the pictures about, because they asked about the shadow, the umbra and penumbra and all that. So if you want to present that, if you can. I'm sorry? Oh, okay.
I'm presenting you now.
All right. Yeah, somebody asked about that, and what I was showing the other day, it was a private chat, but when you see these pictures, like this is a standard model of how this works, and I used to wonder why they would draw the lines like this. Well, they're tangent lines to these two circles, and they'll draw two sets of them, one from the top of the sun to the top of the moon and just extend it out, and the bottom of each and extend it out, and that is the dark part of the shadow, the complete blockage, the umbra. And then the other two sets of tangents are from the top of the sun to the bottom of the moon and vice versa. And where those go is the widest area where the blur is of a shadow. And that's the penumbra, supposedly. That's the standard model. And these are determined, you know, the size of the shadow, as anybody knows with a, you know, hold up a ball and a flashlight, you're going to get a different size shadow depending on a couple of things. And those are the distances between, you basically have three things here. You got the light source, the blocking object, and then where the shadow's landing. And those distances matter as well as the relative sizes. And what, for all practical purposes, people get into this technical term of a point source, but that's really what we're doing. Even though the sun is supposedly big, it's still a point source because it's the only light source in the model. So we should consider it always a point source. And because of that, I did it again. Dagnabbit. I keep rolling my mouse to scroll, and I shouldn't do that when I'm in this photo thing. And so they can calculate those sizes, and what it should be, since the sun, by the time it gets to anywhere near where we can, you know, as far as we can tell, it's the same size as the moon. So when we're doing this model of looking for shadow size, it doesn't matter how big and far away the sun is. For the purpose of the physics of light, it doesn't, all we care about is what it appears to be. And if they're the same size and there's some unknown distance that probably is not very far, we can draw straight tangent lines to the top and bottom, and that's our umbra, which should be the same size as the moon. And then we're still going to have a larger penumbra because of these two tangents, no matter, you know, what the different sizes are. As you can see, even when they're the same size, if you go up and extend these lines, you're going to get a bigger, you're going to get some kind of penumbra. You should. That would be hard to tell on the ground, the difference between the sharp shadow and a blurry one, since we're so tiny. But still, from far away, from the balloon or whatever that people have done, where the totality of the shadow should at least still tell you these two tangent lines, which should tell you something about the distances and the sizes. And so you can calculate these things, but we have too many variables that are unknown in this case. But I'm just saying mostly that this model is wrong when they put a great big sun. That's totally wrong. They should be the same size, and the shadow should be a lot smaller. And the darkest part, at the very least, should be the size of the moon. So it should be a quarter of the size of the Earth at the darkest part. So it should be much bigger than that in totality. Say you even, had this same diameter on both sides. You've got, if this is a quarter of the size of the Earth, and we got 2 more quarters, so 3/4 of the Earth should be covered by that shadow, according to standard models. And another thing was that, as I mentioned earlier about the zooming, you shouldn't, if something is even the distance of the moon, it shouldn't make any difference if you zoom on it because it's too far away. But at any rate, I just wanted to explain about the shadows and the fact that you can calculate these things. And there's a GIF that at this link that you can go and watch it. But you can calculate based on the standard model and see if it adds up. And I'm pretty sure it won't. And that's another thing is people say you cannot simulate this with a model with rubber balls or basketballs or whatnot. And that I'm saying no, you can do that because we don't care how big and far away the sun is. All you have to know is that for the standard model, if you're debunking that, is that there are supposedly 30 Earth diameters between, I'm reading down here, between the Earth and the moon, but 11,703, if you did their model, where all you need is this 30 Earth diameters. Okay, so if you have a rubber ball is the moon, and it's a fourth the size of the Earth, so you have something 4 times that size, and you put 30 of those between the moon and your light source, you can simulate that. And you could easily do that in any field or a large area of any sort. If you say you have a 2-inch diameter moon, and then you put, the Earth would be 4 times that, a ball that's 4 times that, and then put 30 of those away from the moon and then have your light source. That you could easily simulate that. So I don't know why people think, well, it's impossible because of the distance of the sun. Irrelevant, completely irrelevant for that. So it could be done. Anyway, I don't know if that answers the question somebody had in the chat, but.
Yeah, thank you for explaining that. That's what you feel, isn't it?
Yeah, that I drew that in Inkscape, I think I did the drawings. But yeah, I was just thinking about that one day, going, just remembering my physics classes from a long time ago and going, that just doesn't add up, the standard model. Why are they making the sun so big? So there you go.
Bad Christian series. I put a few of Yudit's photographs in your messenger, Facebook Messenger. I wonder if you'd show those for us. To show Karen and Bad Christian.
What are we seeing now?
Yudit, do you want to talk us through these?
Oh, yes, today I've got the sun, so clean sky, beautiful, beautiful sunset. It was very unusual. Every day is cloud like this, harp cloud, but I don't see the airplane in the sky. Few months I don't see airplane, but you see the sky. It's the cloud like this.
That's pretty.
All day, thank you. All day, beautiful sky. And the moment the sun is set, so I don't know from where the cloud come, and this is the sunset we've got every day almost.
Nice.
Yeah, and the sunspot. From the moment I buy this camera, wow, everything is new for me. The moment I see the moon so close to me, I couldn't breathe. Wow, it was incredible. And when people next to me see what I do and what they see the sun so close and the moon, and it's a big surprise for everybody. Yeah. And from this I can start explain it's not the NASA sun, and I can explain the art is flat, and you know when they see the sun and the moon so flat, so close, yeah, you bring them the creation so close to the face.
Mm-hmm.
Beautiful.
Because Yudit also is out every day taking pictures dawn till dusk, aren't you?
Oh yeah, I try also in the morning. I try to picture Venus. I need to wake up 4 o'clock and go outside to do this. Yeah, yeah, I love it.
Those then. Karen, were you going to show us some more stuff?
I could if you'd like.
Yeah, sure.
I got a really great sunrise that I got on the East Coast when I went there about a month and a half ago now. That's me.
I'm presenting you now, and maybe we could see your eclipse day as well, because you've made a video of that as well, haven't you?
Mm-hmm. So let me share. I don't really need the sound. But yeah, I got this video and I thought this one was a really great example of the distortion that happens at the horizon there. Because it's like you can see the sun, it's squashed. It's completely squashed. And you can see the miraging going on, and then you can kind of see that line right here.
Yeah, Yudit captures the sun like that.
When the and it sort of slowly starts to come out of its distortion.
Wow.
Wow, got colours.
Yeah. This is on the P900. This is, by the way, it's the sunrise sunset setting. Is if you just use a regular setting, the colors are really dull. And I was so glad I figured it out before I got this sunrise. If you use the sunrise or sunset setting, it really captures all those oranges and pinks and purples and everything that you see, with your eyes.
Beautiful.
I'll have to try that. I don't have half the settings figured out. I mean, there's so many things you can put on that camera. I don't.
Yeah, you just got to try it. You just got to try them out and see how they work. But under the scene setting where, it's got all those presets, the sunrise and sunset setting is awesome.
Yeah, I'll have to do that. I had grabbed a few shots of sunsets, and I was disappointed in the results, and I wasn't sure why. So I'll have to do that.
Well, I'm telling you, use that setting and you'll be happy.
Okay. Well, now we have to have a good sunset. We're expecting rain for the next week, of course.
It's got quite warm in the UK at the moment, for a change. But it gets called it. It's just always really sticky heat, humid.
Oh yeah, that's how it is here too. Because I'm in the southeast United States, and the whole East Coast it's pretty muggy. And did you want to see the regular eclipse video, or?
Yes, please.
Okay. Eclipse.
Yeah, talk us through it a bit, Karen.
Okay, hang on one sec. Okay, so here we go. This is the eclipse. I thought it was kind of unusual. I was getting this effect here where the very points of it almost look like, I don't know, they were like, I don't know if it was, I don't think it was out of focus because I was using my solar filter, but push it along here. At some point, you know, it starts to like, I don't know what that effect is.
I don't know. It might be just because it's this very small point and high contrast.
It could be. One of those weird effects you get with the solar filter. Let me fast forward it a little bit. Oops. Get a little bit of the beading effect. What do they call that? Those beads? I forget.
Oh, yeah.
You know, it's like they got the diamond ring and then there's the beads.
Boy, I can't think of it either. That's cool that you got that. I'm hoping if we're still here in 7 years, that we'll get the same.
Yeah.
Experience the same thing.
Yeah. So right when totality hit, I just took the solar filter off, and I just, you know, those rays that you see, I mean, they pop right out all around here, and it, you know, it kind of looks like, you know, kind of like a magnetic field, sort of. You know, that's how I see it.
Yeah, it seems to me that for the eclipse, we're missing the rays that are coming straight toward us. And so these rays are there all the time, obviously, but they're probably just the same as the normal rays, I would think. They're just the ones in the other directions that we never see.
Yeah,
You know,
I don't
normal
know. I
circumstances.
mean, when totality hit, it's like, I've said this before, but you know, the sky goes dark, but it's not like twilight dark. It's not.
Right.
It's a really weird silvery gray light, and it just, the only word I can use to describe it is like, it's almost like a polarized light. And then the planets that started showing up, because we didn't get the star effect, which is another thing that I thought was really weird, because Bob and Cammie they said that, you know, they were in the path of totality, but they were out in Nebraska, out in the country, and they said it got dark like nighttime and they saw a bunch of stars. Well, when it went dark for me, I mean, and I was right in the center of the path of totality. I got 2 minutes and 37 seconds. I checked my timestamp on my video. I mean, that's like the longest anybody was getting was 2 minutes, 40 seconds. So I was right in the middle, and I didn't see that many stars. Only the brightest of the objects, you know, came out. The planets came out, like Venus came out, and it was bright pink. I mean, it looked like a big pink light in the sky.
I do know that even with the 90% we had, the light does look different. It's not like any other light. There's a frequency missing or a
yeah, it's totally weird. It's like it's polarized. It's like something's being canceled out. The light being altered.
Whoa. That just looks like, I know you haven't, but it looks like someone has put CGI on it. Sorry.
Yeah. And if I turn
You
up,
didn't know better.
If I turn up the volume, you'll hear me say, "Well, look at the camera. What is that?" Because you don't see that with your eye.
It's coming back. It's coming back.
I think one's gotta be Jupiter and one's gotta be Venus.
Whoa, look at the camera, dude. Look what the camera's recording. Holy crap. Did you get the shadow bands?
Oh yeah, then we recorded shadow bands. We had the poster board out. We recorded some shadow bands too. We got that effect. And then I got my little UFO right here floating through. I still don't know what the heck that was, but it goes all the way across the screen.
Wow. You know, I have to think, just knowing how many lenses there are in the lens barrel, that's got to be some kind of, because the intensity of the light, and it's a very actually small point as compared to the rest of the frame, that it's got to be something to do with that, because you have so many lenses in there with, you know, there's that difference in density thing again, that it could do that. I would have to sit down. I'd have to know the complexity, and it'd take me a lifetime to figure out what's going on mathematically, but that's all I can figure. If you didn't see it with your naked eye, it's probably a camera lens.
Oh, I'm sure it is. I'm sure it is, but it's just a really unusual effect. I mean, you got the red and the blue spectrum showing up.
Well, that makes sense too, because they have to correct for specific colors when they put those lenses together. You know, to get rid of chromatic aberration, they have to do that.
Wait, what? You know what I just noticed? Oh my gosh, I can't believe I didn't notice that before.
What?
When I was pointing out that I had a little, because like you see stuff floating around the air, pollen and whatnot, like dust particles, you can see it happening. But then there's like this one little object that kind of, it looks like it's on a trajectory, like right here. And it's going up like this from the lower left to the upper right.
Yeah.
I showed my picture, didn't I, on that hangout with you the other day about the fact that I've seen them.
Check it out. There's another one comes and does the same exact thing.
Several.
Like after my son bumped my tripod, and then I was trying to get it back. Right after that, I just now noticed that another one comes from like the same direction and goes here, right here. It's going in the almost the same path as the one before it. Oh, that's crazy.
I've seen those before, but you don't see them with your naked eye. You only see these things when you've actually recorded it.
Yeah. And then here you can see stuff all flying around. It's just weird. Just you see all kinds of just unusual things during the eclipse. This light is just not behaving normally at all. Anyways, that's like the end of it, because after that I couldn't get it back. But
I've captured those things myself, and there's usually two of them together, and they're moving so fast that you can only really get them to see them when you're on slow motion.
Yeah, I mean, I
I
played
mean,
that.
what are they? They're always there with the sun.
Yeah, it's just so unusual. And then let me
I'd have
see.
to go back through my pictures. Do you remember my? Oh, I know why. I was looking to see that they were sent to series, but I put them on that other Hangout, didn't I? I got my pictures. Oh no, series still did it, didn't he? He still put my pictures up. I can't see them on here quick enough, but I've got loads of pictures of those dot things moving.
And then this is the shadow bands. I don't know how it's going to show up because when I put it in my video, I had to enhance it to make it show up a little bit better. But you just sort of see them flashing across the poster board. I don't know how well that comes across. Probably not very well. Are you guys seeing that?
It's quite big on. It's quite big on the piece on there, isn't it?
Yeah.
Just about see it. Yeah, it's a little bit faint on the Hangout.
I might, if I probably look better if I did it through my video where I enhanced it. Let me try to pull that up real quick. Okay, Google, let me change my window. There we go. And let's see. Here we go. So first I just played it normally. And then I redo it enhanced. So yeah, there they show up a little bit better. And that's kind of close to what it looks like when you're looking at it in person. It's pretty obvious that it's going on.
Did you both have to actually get the eclipse like from it touching the moon? Sorry, the moon, whatever it is. Sorry, it's a moon eclipse, isn't it, on the sun? But that shadow, how long did you get the shadow from the beginning of touching the sun or whatever it's doing to the end? Both of you, did you at the same time? Is it
of totality? Like how much totality did we get? Or yeah,
well, the
2
whole thing.
minutes.
How long? Oh, sorry, carry on.
Well, okay, well, for the whole eclipse, it was about 3 hours because it started just a little after 1. It was like 1:09 p.m. and then it totality hit at about halfway through at about 2:38, between 2:38 and 2:40. So it's 2 minutes and 37 seconds of totality, and then a little after 4 o'clock is when it ended.
Yeah, we had about 3 hours total from beginning to end, but totality, I don't know. I didn't take video, so I can't get the timing on it, but it lasted enough that I got a fair number of pictures of it. So I'm guessing totality, well, 90%. It from the time it actually started to move off from a crescent, I don't know, maybe wasn't that long. I don't think it's maybe 10 minutes. It just wasn't that long.
Wait,
You're going to show us some more?
what was 10 minutes?
Oh yes, series has got them up. Series, go back to the other ones. It wasn't those. It was the other ones with the dots on.
Just the main where the crescent was straight up and straight up at the top. Just that part. That's what I was meaning.
Mm.
I'm just guessing too because I really wasn't paying attention to the time. I was just trying to get good shots.
Yeah, it gets a little hectic, doesn't it?
Yeah, and I was trying to manage 2 other devices. I had my old camcorder plus my scope with a phone on it, and those 2 didn't seem to work out too well. I couldn't get sharp pictures. So,
Yeah.
but I was juggling a whole bunch of things.
Yeah, I had another camera that I had set up, but totality it was so fast, and like the other camera, it's a bigger lens. It's like 1,000 millimeter lens, and I could not get it in frame of the camera. And then to try to take a picture too after that, I was like, I gave up on it because I was like, it's gonna end. It's gonna end, and I can't do it.
I just couldn't get my camera lined up on the scope. We could look through it, and we eventually just used it for that, for people just watching. But like I normally can get the camera lined up on the bracket that holds it over the eyepiece, but I just couldn't get it to work that day.
Yeah, it was
Those
kind of
pictures kind of look unreal.
I
It's
know
just as well we know you're a real person.
There's the kidney bean, son.
Yeah. Yeah, it got crazy. I was like trying to do everything.
Yeah, you need like 3 or 4 people.
Yeah,
Oh,
you're like, this is
do you
my
see what's on
chance. I
top
gotta
of
do
the
this.
sun?
Hmm?
What's on top of the sun? There's a
Yeah.
star, one of those things again.
Yeah. Yeah, that's weird, isn't it?
You know that I've taken some because we with the hangout with John the Morgul on Candy's hangout. I showed you mine. Siri showed you mine, so you know that I've got pictures of those things flying around the sun.
Mm-hmm. No, this one
Mine
almost
are in the daytime. Mine are in the sky, the blue sky, whereas yours, because your zoom and everything, they look black, doesn't it? But it's daytime. Well, it's going black, I suppose, isn't it, because of the eclipse?
Yeah. Well,
But yeah, I've got them.
Yeah, this is without a filter because I hadn't put the solar filter back on yet. But that looks like a little ball, doesn't it? So yeah, these are just some still shots that from the video. I mean, this is kind of a weird effect too here when it starts to reveal the sun again.
Mm-hmm. Almost like we're getting back more of the spectrum again at that point, the color change.
Yeah. Nope, there's one of those little things.
I wonder if anybody else has caught these little things. To get my pictures up to show you that I've caught them as well. So Karen B's not the only person that's like has seen those things.
Yeah, those little random things floating around. But I mean, and it's weird because it's like, when you're watching the video, you see stuff flying around because there is just stuff in the air. There's dust and pollen and whatnot, and you can, but these little things, they're like on their little path. They're going in a very specific line and a steady.
They're here, do they? They actually look like they're there.
Yeah.
Right.
Flying in front of your camera.
Yeah. It's definitely different than dust and pollen.
mine up now, so I'll send them to series again.
I'll have to look through all my pictures and see if I see any little dots. I wasn't looking for them. Probably missed some.
To do, yeah, I've got to do it through the. Just give me a couple of seconds. I need to go to series, messenger. Got to find them up. But what they are, I just thought that maybe they were harp. Well, they're messing around. I'm just getting the pictures out. There's just hundreds of pictures behind. Series, Yudit sent a picture of the sun, which you can show. I mean the moon. Sorry, she sent a picture of the moon. Because I'm trying to do two things at once. Overload! Oh, they come. Me, so many pictures behind. Oh, it's past these. Come on. And then here they are. Gotcha. I mean, again, I had loads more of them. I must have had about 30 of them I'd taken pictures. But as you say, on your iPhone, you can only keep so many pictures. Anyway, series, you there? Series. That's it. I've sent you some more pictures. Yudit sent that one in. Got quite a lot of colours going on, isn't she?
It's the moon I pictured yes last night, and it's very similar to this picture. Yeah, you see.
Okay.
And I never get picture like this. It's a new position. And yeah, it's yeah, first time I see this.
Funny how it is a perfect grid.
Yeah, you've got like crescents everywhere.
Mm-hmm.
Yeah, and the green. You speak about the green.
Oh, I see what you mean.
Grid. These spots line exactly. If you join the centers of these spots together, then you get a straight grid. Yeah, grid. Perfect grid. Like every individual pixel in the lens itself actually reflects it back on the lens. Something what happens with phones mainly. So far, I think you can't see this with your bare eyes.
Series, I've sent you so I sent them to Yudit by accident. I've sent the pictures of the actual dot things that I've seen. Again, they're off my iPhone. And those things are flying around the sun. I know you can't see the sun there, but they are. They're flying around. They're so fast. I don't have the videos, I don't think, anymore, because I couldn't keep them all on my phone. But I think there's 3 of them, even though I'm only showing 2.
Okay.
At the horizontal, the one below. The horizontal.
And I know that you can't see the sun, but they are exactly the same thing. On Sun and Moon, our group, there's more pictures. It would just take me so long to scroll down. We're talking of, I don't know, we're talking of about well over a year ago, and I've got thousands of pictures on my phone. So, and there's thousands of pictures on the group. To actually scroll, it would take me about 20 minutes, half an hour to scroll down the pictures. So, but those are around the sun, just the same as Karen B's.
Need to get those off your phone.
The group.
Oh, okay.
But I mean, if you want a copy of
Well,
them,
I mean,
I could give it to you.
Mhm.
I mean, what is that? What are they? And they're moving really fast.
Angels? I don't know.
Who knows? I've seen them. I have some video of some I took years ago with my low res camera, but there was one. I only saw them because there were very bright flashes in the sky away from the sun, and I wondered what they were. So I zoomed in, and it was just a silver ball. Looked like to me it would flash very bright every once in a while, and then at first you think, well, it's a silvery balloon that somebody let go. You know, it's just turning and reflecting the sun. But then another one came along, and it was flowing in the opposite direction, so it couldn't have been balloons blown by the wind. And I never did. You can't tell any detail. They're just silver balls. But the weirdest thing was the next day, I went out with my still camera and that I had at the time, and I was looking for them, but I didn't see them. And then I sensed something over my head. I didn't hear any other way. I just had the urge to look up, and there was one over my head towing something behind it that looked kind of oblong. And in the time it took me to raise the camera to my eye, it was gone, just disappeared.
Well, there's all sorts of things you notice now that you never noticed before, isn't there? I mean, do you go out wanting to look at clothes shops and jumpers, or do you go out thinking, right, that's there, right, what's that? Oh, look at those chemtrails.
Yep, the whole family's noticing the chemtrails now, and they see them in movies and everywhere now. Yep.
Do you both get the chemtrails?
Oh yeah.
Oh yeah, lots.
Tons. Yeah, it's pathetic that even sometimes when there's a storm and you see a break in the clouds, you see a chemtrail going across it above. It's like, don't we have enough clouds already? Do we really need you to do that right now?
Yes, that's exactly what I think. Do we need any more?
Yeah.
Yes, we do. We can't, especially here in England, we can't see what's happening, can we, from the ground then, when we've got a great big thick cloud.
Right. And I just saw a good video this morning putting together with chemtrails with the hurricane in Texas right now, that how very obviously steered it was. And they're keeping it in that spot to ruin Texas. They don't, for a variety of political reasons, but that the chemtrails, the components in the chemtrails allow them to steer the weather, to control it better. They can steer their hurricanes and things that way. So that's at least one of the purposes of the chemtrails, with the barium salts especially, is so they can do whatever electrical, radio waves they shoot at it to push the weather wherever they want it to go. So that's at least one of the purposes. I thought it was a good video.
Yeah, they've got cloud making machines, haven't they?
Yeah. And they say that the Doppler radar stations, actually, they can see them on, videos of the satellite, supposedly, videos where they show these plumes of clouds of condensation, that they're making into clouds from all the radar stations, that they're coming up from there. So that's the purpose of Doppler radar, is not just to watch the weather, but to make it. And that they shoot these beams at the chemtrail infested skies and make whatever they want to make.
Yeah, I've got a bit of footage. It's a little video. I can send it to Series because he's the best one to play it. But it was when I went to Denmark. I saw a sun dog, but I saw it on one side, then the other side. I saw a black rainbow.
Wow.
I'll get that one. Have you ever seen a black rainbow?
Not a black one, but I've seen black chemtrails. I saw one actually be fired out of a jet. I couldn't, I didn't have videos fast enough, but I saw it happen. I mean, it actually shot a black particle beam out of the jet.
Really? You saw it?
Yeah.
Because I've taken loads of pictures where there's those paths, like there's this black path and then a plane comes along afterwards.
Yeah, I was watching this plane. I was just in the habit of watching the plane since I had learned about chemtrails. This was, I don't know how many years ago, but I was watching this one ordinary looking plane going kind of slow and low. And suddenly there was like a backfire, when you shoot something, shoot a gun, there's a backfire, a little bit of black out the back, and then straight out the front, absolutely straight line was this particle-y, powdery looking beam. And it followed along the beam, and as it went, the plane got fainter and fainter, and you couldn't see it anymore. So it was just weird. I got the tail end of that footage, but it was very blurry and, hazy.
Well, on my phone, I've got some really weird objects in the sky. They're definitely not aeroplanes flying through the sky. Whatever it is, it's not an aeroplane. But we'll maybe do that another day. Maybe we can do a night where people try and send in photographs of these weird things they've taken pictures of.
Yeah.
But I'm just going to get this video up. Oh, no,
I have a collection of those too. And by the way, before I forget, did anyone else see chembos, what I call rainbows in the clouds around the eclipse? We had so many clouds that maybe it was more obvious. Yeah.
John the Morgar was showing that, wasn't he, Karen B, the other day with his aunt's pictures?
Yeah, I think so. Mm-hmm.
Yeah,
well,
I
didn't see anything like that. It was actually pretty good skies where I was. I got lucky.
Yeah, I guess that was one of the silver linings of the clouds here, was that we could see that there were chembos when it was eclipsing.
I'll just unpresent Series now because he's showing that. Oh, I'll just I'm just getting the video. I'll just stop presenting him for a minute. Otherwise, the dots are there. They are weird. Do you have any idea what you think those dots could be? Because they're the same as what Karen B's picked up on. On the panel?
No idea. No idea.
I'm sorry, what was the question?
I don't think a lot. What you think they are? A lot of people don't seem to have ever mentioned those dots flying around the sun.
Man, I don't know. That's why I was asking when we were on with John if it was like, if anybody thought they were like maybe balloons or something, like weather balloons. I have no idea.
Swamp gas.
They're moving too fast because I've videoed them and they're going really fast. Sending you another video now. I don't know how good the quality of the actual flying is, but sending Series this video. It's only about 5 minutes long. Series, put the volume on. But it's when I went to Denmark because I was just 6 months into flat Earth, and suddenly there was these things. Series.
Off somewhere.
Maybe he's got people there because he's muted himself. He's not looked at his messenger yet. Series. What it is I'd play it, but I just don't have a good enough.
It takes a while to get the video.
Okay, but I don't see that you picked it up. Okay. It says delivered on Messenger. I can see it's delivered. I suppose I could try and just put the link. Oh, there he's got it now. Volume though. There's no volume, series. Series, there's no volume. I think it's because he's muted himself. You're muted, so we can't hear anything.
Sorry.
It doesn't look at all any different to before I was in that. I look at in my.
Not just the color.
I can't believe I've never seen that before. When you can see the colours changing in the sky, and it's a line like a pyramid.
I think it looks more like a layer of moisture.
It doesn't come across very clear here, but there's a line going from that cloud. Pronounced now, is it? The colour change, but you saw it, didn't you?
Yeah.
Oh, there it is.
Yeah,
It is there
I see
still,
it.
but it
Just have to tune into it.
wasn't on any of the other clouds.
I think, you know.
Oh, I've never seen that before.
Of something.
Oh,
And then rainbow.
oh, it is, isn't it?
Reflection of water because it's a real misty out there.
It's really annoying. I don't think the camera's picked it up. Oh, I think it has actually now. A black line. Never ever seen that in my life before. It's there. Ew. How can you have a black rainbow? Oh, you can see white on the outside.
A little on the top of
Ooh, have you ever seen that before?
if you look
I'm not sure it's a rainbow shape or not.
closely.
If it's arc or not, you know.
It just looked a bit like a rainbow. just without any colour in it, just blacks.
Yeah. Tune into it, and you see the
To
start
me, that looks like it might be an anti-crepuscular ray.
Oh yes, I see what you mean. Just there.
Just over.
Yeah. My camera's picked that up, I think. It's one of my first videos, by the way. Can't see where I'm flipping videoing. That's called a sundog because the sun is there, and then it's called a sundog. It's reflection. Yeah, but then the flat Earth people would say that that's a reflection of the dome. Since I can't see a flipping. Oh, look at now there. But it isn't even. Ooh, can't see it on my camera, can I? Where are we? I'm not staring at the sun, I'm looking at that rainbow on the side of it. How the hell does that happen? That's this rainbow sideways. It's only with my iPhone, by the way, not a camera. We get rid of that one. Okay. Okay.
The clouds where it is here, there can't be a rainbow.
Yeah, but it was on the other side just a minute ago. How could it just turn up on the other side within minutes? We've only walked about 10 yards.
It's not. This is another part of the same thing. It's not that one that to there.
You think that's the same one?
It is. You cannot see it, but there's a ring around in that distance from the sun. And all the way conditions were there with voice, there would be a circle that would reflect those water. Sometimes you only see part of it right now. It's only very small parts. Much more.
Stop it now if you want series. It's just to show how low the clouds really are. Now we're above the clouds.
It's listening to a lawnmower.
It just takes That amount of time to get above the clouds. And people don't realise how low the clouds are. Just like gobsmacked to how low the clouds are.
I've heard a lot of people say the cloud deck is lower than it used to be.
I think it is. Yeah, there are clouds in the sky, aren't there? But, you know, up there in the sky. But a lot of the time, they're really low. And when you watch Stan Smith, he's got a camera set up on his roof. Basically, it looks like the clouds pass, like, just overhead. I don't know if anybody else has thought the clouds are really low.
I've got some weird sky stuff, cloud things, if you want to see it on a little video.
Sure, go for it.
Alrighty.
I've just presented you.
Okay, thanks. This is just, it's one, actually, I have this on my YouTube. I forget what I called it, but these are shots from a number of years, just from my backyard, mostly. Or, you know, sitting in a parking lot or something.
Huh?
That one's got dark and light.
Wow. Wow.
Handprint.
That was a sunrise there.
Oh, I recognise those clouds. We get them.
Yeah.
Now that is harp, I think. Oh yeah, I've got pictures like that.
Yeah, and then a shadow upwards from the plane trail. It's so like water. I mean, we live in the water, it's in a sense.
We did not get a storm that day looking at those clouds. It was amazing that it didn't storm.
Yeah.
There's what I call an anti-trail. It's like a space in the clouds where a trail used to be or something.
Yeah.
That's weird.
Yeah, it's also kind of, there is another trail and that's actually blocking the light for the clouds, and so it cuts out the light in the clouds.
This is still my old camera, by the way, the 1 megapixel. Those planes, people don't realize they're very hard to track.
They are very hard to track. Even with a tripod, they're hard to track.
Yeah, they are. I agree.
I agree.
Yeah, it takes dedication to do something.
This is such an obvious chemtrail jet. I mean, with the spaces and the smoke like that. That's what they do over our house.
Whoa, same as. Oh my goodness.
If it is it a harp below, then it is a harp above.
And we are near an Air Force base, so there's that.
Incredible.
I call that a half zipper trail.
To be controlled by the military's part.
Oh, absolutely, yeah. And there's one that just stops.
That's
Just
the
like
only
that.
part that motivates everything.
There's the half zipper.
Wow.
To stop them, we must be in the airport. In
This is-
all the airport and stop them. Don't let them fly.
I think
Yeah.
some of them might be drones too from a military airport, and there's no way we would get in.
So we have to check it out because I believe they fly from the regular airport.
I think, yeah, I think there's both.
Undermine this particular stuff is just by undermining the whole system what supports it. And there, the biggest dilemma is because we never learned actually to not support this system, to actually
Right.
support themselves or the community in that sense, the people themselves instead of the corporations, because it's always the earning of money what you need because you own something, because you lend something to have something.
There's
And it's
an
always
orb of some sort.
wow.
Sorry.
I sent a video, Karen, to you. And they speak about this. They start to spray in the sky from 1917.
Wow.
Yeah, before the after the First War. Yeah, 17. Yeah,
That's it.
they spray in the sky. So yeah, we must stop.
Well, I've got
that.
some pictures I'm going to send to series right now. And then a video to show you, like, oh, this one day I just couldn't believe it. I'm just going to send them to series. They're not all the pictures I've got. They're just ones I've got my hands on right now. Some of them are here and some of them are in another place. You can go through those. Right, they go series. I've sent them. They'll just take a second to come through. And then I'm going to send one of a video. Right.
No, whole collection.
Yeah. And I'm sending you 2 videos that will take a little bit of time to come over just to show you what was in the sky at my family house in Reading, which is about, I don't know, 15 miles, 20 miles from me. Just take a second to come through. Anyway, series will show these. These are the kind of skies we get. I'm presenting you now, series, and the videos are there. They just got to come through.
Yeah. I don't know. It doesn't matter where
On
I
at the
play it.
moment. It's just your icon at the moment, series.
Yeah. That's what I say. It doesn't open. Maybe
Doesn't it?
Screen.
When I was in Hungary and I see the airplane in the sky, so I ask the young people if they see what the airplane do in the sky. They look at me like I'm crazy, you know. They don't know what I'm talking about. Incredible.
Most people don't care, really.
No, they don't care.
They don't see. They don't see it until you tell them, you see, 1, 2, 3, 4, 5, 6, 7. Why? What they are doing? Yeah, they don't see it.
How's it going, series?
Oh, the images won't open. The other one.
Shall I send a few at a time and see if they come through better then? Oh, dearie me. Live research, hey, guys?
It does open.
It does open. Cool.
Where is my share? There is my share.
I don't know what they are exactly, but those clouds are just so weird. This is a few weeks ago.
Yeah, like a tractor in the sky.
Yeah, and then this was on my iPhone, but I've got some pictures from my
Wow.
to go up, but just the colours, and I don't know what that was. That was just appearing in the clouds in front of the sun because the sun was coming from behind those houses.
Yeah, weird.
Cats.
It was weird because you can see the sun hasn't come yet. It's behind the house. And then these things, this is what was, these the clouds were like in Denmark when I was filming. They were all like that, like they were fizzing. I'm pretty sure it's them with their harp thing. I mean, just look at those chemtrails as well. Let alone what the clouds are doing. Yeah, the dates are on the June, these were. This is really early in the morning. It's my favourite time. I don't know about yours, but I love sunrise or light rise. I love it.
Yeah, I see the video from this morning, Karen. I see it terrible.
Yeah, I haven't put that video on because I took it off my phone because my phone's getting so full up. But now we're going to Reading and they're backwards, these pictures. They're the other way round. You know, this was the last picture I took. But I mean, that's all we could see.
Yeah, this is incredible
Look at them.
because they put the sky everywhere, everywhere. Even if the children movie.
And just look at it.
Yeah, they've started. Well, for a number of years now, they've put chemtrails in movies. You know, they make them deliberately.
Yeah, everywhere, everywhere.
Yeah,
There's hundreds of the things there.
Look.
That's me panning around.
Look at it. Look, there's a nasty plane up there making one. This has all got chemicals in. And then look, Cindy, see, they all stretch out. You see that there? Look, and they turn into clouds. See that there? That was a contrail that size. And now look at it. It's turning into a big cloud. And they cover the sky up. Yes, it's disgusting. But you can see what it really looked like from here to see all that in like, God. I've been to see my in-laws and I've come out to... Just wanted to show you.
That's another one.
Over Reading.
That's a couple of hours later.
Yes, I'm filming the chemtrails, Timmy. I'm filming the chemtrails. They think I'm mad because I'm filming the chemtrails. Look at them. Look at it. It's a great big grid above my head. Do you see them? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Disgusting.
Yes, disgusting.
Show you the glorious chemtrail.
Yeah, is that all the pictures then, series? Because I sent you loads of pictures. Oh, it doesn't matter. Get the idea. Covered in chemtrails.
And it up with the videos.
Or at least the video's played. Karen, is there anything else that you want to show? Is there anything you want to talk about?
I mean, I can't really think of anything offhand. I'm really bad at this. bad at doing unplanned talks.
No ad-libbing.
We've been going to...
This
Carry
is
on,
SOS.
Yudit.
This is SOS. Yeah, we see it every day. Yeah.
It just seems really bad. We used to have clear skies.
Yeah, people, I remember in a message boards once, years ago, that I said, when I was a kid, the skies were really deep blue. and the clouds were different. They weren't jaggedy shaped, and the jet trails were short V-shaped little things. And they're all like, "Oh, you're just senile," because I was so much older than them. And, "Oh, your photos have gotten deeper colors over the years, so we don't even believe your pictures." And I'm like, "What? Photos fade with time. They don't get more vivid." That's how desperate people are to think that, no, it wasn't any different in the past. It's always been this way, just like a page right out of 1984.
It's the denial of science, of real science.
Mm-hmm. I think also
they forget that everything comes only empirical to prove it. To actually learn something, you make anything empirical by doing the practice of it. I mean, how else would you actually do something within a science? Well, so far we figured we are only educated into slaves to just know enough to operate the machine, but not know why.
Right.
Well, I just don't remember the skies looking like they do now.
They didn't.
They didn't. Yeah, they didn't look like that when I was younger. And even because I used to live in California, and I moved out to North Carolina in 2011. And for the first couple of years, I was like, "This is great. These skies are clear. I mean, it's normal. There's not a bunch of crap in the sky." And then in 2014, man, we just started getting hit so hard. And it was crazy because I watched a video about chemtrails, and it was supposedly like a whistleblower chemtrail plane pilot, and he was talking about how, and this was California was going through a severe drought, and then he was talking about how they were trying to push the drought out to the East Coast, and sure enough, after the summer after I saw that video, they just were spraying so heavy out here, so heavy. And normally out here it rains a lot. I mean, it's basically like a rainforest. It rains a ton during the spring and summer. And once they started hitting us, it was like almost like it turned into basically a drought, and a lot of farmers were losing their crops. And I remember looking at the local newspaper one day, and it's like, hey, on the front page, it was like, if you're a farmer and you lost your crops and you lost profit due to losing your crops, call this number to get government assistance. Mm-hmm. And I was like, man, that's it. They just want you dependent on the government. It's like they're doing it on purpose to make you feel like you need them,
Yeah, everything like that, isn't it? I agree with you. It's all set up so you become dependent on them.
Finding everybody is stuck in it,
Instead of us becoming dependent on ourselves, maybe, or growing, we're now dependent on them for everything.
Yeah. You want to grow your own food. You want to be, self-sufficient. Nope. They don't want you that way. They want you to think that you need the government. I mean, and you don't. We don't need them.
Right.
The thing is, what is the word govern? Government. It's not meant to be your friend or help you. It's to govern you.
Yeah, it's mind.
All we've done, what we don't realise we've done is we've just given all our powers away. And they keep changing the laws and making them better for them, just to control us. I mean, have you ladies heard the bit about the fact that your birth certificate is actually a death certificate, which they use on the market to make masses of money out of each person?
Oh, yeah.
Do you know?
Collateral. Mm-hmm.
Yeah, we're just collateral. And it sort of becomes harder to want to sign anything, doesn't it? Just what am I putting my name to this time? Before I just used to do it.
Yeah, or because then you got to go, down to the local driver's license office, and you got to get a driver's license, and they want you to check, are you a U.S. citizen? And I'm always like, man, I just want to say no. But
yeah, something I used to
make life difficult for yourself if you try to do it that way.
The things I used to be proud of, I'm not proud of anymore.
Yeah. Yeah.
Things that used to mean something just don't mean anything anymore.
No. You realize that they're taking away what should be your God-given right, and then they're charging you a license fee for you to take back your God-given right, you know?
All I can see is by lying to us the way they have, all they've done is to take our freedom away, one way or another.
Oh yeah. And you know, they're making money off of you. No, it's all about money.
Yeah, well, it's it. And the thing is, if they already make millions of pounds out of you anyway on your death certificate, it's like, it's just one great big con, isn't it? And they've got us drum us down, which is why they've got you glued to the television and so forth like that, watching all that crap by thinking the news is real and all that. It's terrible.
Yeah.
Do you watch the television anymore, girls?
Not me.
No.
Don't have.
Don't have. Series, you're a man. Do you watch TV?
My TV became my monitor.
You became what?
Right.
My TV
His
became
monitor.
my
Oh,
I only watch what I want to watch, not what another has programmed me to watch.
right. We only watch movies on ours now. Yeah.
I watches the television.
Kind of had a movie addiction, but yeah, since that flat Earth happening, I have more flat Earth addiction or research addiction.
Mhm.
Because I really want to know what the fuck, you know, how does that work if it's flat?
Yeah.
Everything is turned upside down and inside out and outside in. I mean, so far I figure we're trying to put what we personally see in the sky into a perspective of actually a complete planet or plane of inertia. And we forget actually to put ourselves in the center. That's probably the core of how the sky works around us. And that's where it's, yeah, the truth is stranger than fiction in that sense. I call it even some truth is so strange that it's stranger than all fiction we can imagine combined. So yeah, that the whole why behind it, it's a bit hard to actually figure out. But what is happening, we can actually figure out because we're actually the witness.
Yeah, and just when you think you're getting there, you realise there's another set of questions to be answered. Just when you think, oh, I've got that thing now, and then you start looking into it, and there's more questions.
But actually, as a joint effort, as a humanity, to figure out where we are, because we need all the minds there are, in that sense. All the ones who actually try to use their minds. I mean, there's so much program what is automatically expressed in that sense as a reaction on the action, the chaos, and then the emotions thereover, and then the whole happening through humanity by that programming. See 9/11, what kind of shock that brought. I mean, yeah, I figured if that didn't wake you up for the first wake up part, and then flat Earth will probably.
Right.
Can I just say something? There's a message from Chris, by the way. Chris is really busy at the moment doing things at home, and he's going to get a presentation ready, and he's just really busy. But what he says to you ladies is, could Karen P or Bad Christian, if they have a Google Drive or something, and would be able to share the original pics so that he can play around with them, ladies?
I don't have a Google Drive. Trying to think if I have anything. Do you?
Mm-hmm.
Question of creating one.
Just somehow send the messages. I suppose if you email them to me, I can pass them on to Chris.
It's as soon as you have a Google email address, you can automatically activate all those kinds of features like a Google Drive.
Or does he want it that way because when they render on Facebook or anything like that, you lose a bit of quality?
Yeah, it's
You use a lot of quality when you put it on Facebook.
Yeah.
They tend to compress your images, so and that's a kind of feature to keep the data flow low. But with that, you actually destroy the original image and a lot of data. And yeah, that's not a good medium to transfer any files through if it's about images.
Karen B, you speak to Chris, don't you? You send him stuff, don't you?
Well, through Facebook, I haven't had that that much correspondence with him, but yeah.
Well, he'd like to see some of your pictures, if that's okay, ladies.
Yeah, right now I'm going to compress them, and then I will upload them to my drive, and I will send them a link.
Hey, thank you very much. And in series, Artist, he's in the chat room, but he's sent me a video to show you them turning the chemtrails off. So I just wondered, I've sent it to you. Do you want to show that film? It's not very long. Just because it was the subject of chemtrails and it was actually a plane turning it off. I'm just presenting series. Take a couple of seconds. My series gets that up. Not that one, series. The next one. We've done that one. You should have one, chemtrail planes turning on and off.
Oh, I scrolled up. There. Oh. Stupid public title.
Well, I presented you now. Yeah, that natural. Thanks, Mary. Nasty chemtrails. They're not natural. I'm sorry.
Nope.
In the sky all the time. It's just crazy.
Playing with life. It's all there.
Yeah. Usually wanting to cover up the sun. Anyway, ladies, we've been going for 3 hours now. Do you think that coming up, because we've been going for 3 hours and it's, you know, when one hangouts all the time, it's quite...
I think so, yeah.
Sure.
If that's okay, everybody in the chat room, because we've talked about masses of things today, and it's really great. And thank you so much, all of you, all the ladies on here tonight, for all their...
Thank you.
Thanks for having us.
Yeah, thanks for having me.
On Sun and Moon mostly is come back to have a group hug. So I'm going to put my camera back on. Hey, there I am. So ladies, you come back for a group hug. Series, look, you can't wait. He's in between all the women.
He's not complaining.
Hey. No, anyway, thank you so much. Hopefully you'll all come back, and a group hug, and we're back tomorrow. Tomorrow we've got Mark Sargent, Patricia Steer, Oliver Ludlow, and Gary John, who's doing the UK convention. Okay, thank you so much. Group hug, and thank you very much for watching and listening, and to everybody in the chat room. Anyway, it's goodbye from us. So thank you, ladies.
Thank you. See you, everybody.
Bye, everybody.